Now here the question is, a chess match between two grandmasters X and Y is won by whoever wins first a total of 2 games. X chances of winning, drawing and losing are A, B and C respectively, and they are A plus B plus C equals 1, and games are independent. So that means winning, drawing and losing, they are mutually exclusive and exhaustive. Now first one is, find the probability that X wins the match after n plus 1 games. Now X is going to win after n plus 1 games if in the n plus 1th game X wins and in the remaining n matches it should be 1 win for X and it could be n minus 1 draws, or it could be 1 win for X, 1 win for Y and n minus 2 draws. So these are the possible ways in which X can win the match after n plus 1th game. Now let us call this probability as P n plus 1. Now one match, 1 by X. Now which one? So it will be this NC1 and then it will be this A. N minus 1 draws. So it will be B to the power of n minus 1 and then n plus 1th game A wins. So it will be this n times A square B to the power of n minus 1 plus the second case 1 win NC1. Now 1 win for Y, n minus 1 C1. Now this is A, this is C, B to the power n minus 2 and again n plus 1th win. So it will be this A, so it will be plus n minus 1 A square C B to the power of n minus 2. Now we can take A square common. So if we take A square common, we can write this as, now here will be this n B to the power of n minus 1 plus n minus 1 B to the power of n minus 2 into C, which is A square n into B to the power n minus 1 and n minus 1 B to the power n minus 2 into C, which is your option B. Now in the second question it says the probability that Y wins the match after 4th game. Now we have already calculated it for X, and the difference between X and Y is their probabilities of winning and losing are interchanged. So we'll actually use formula in first to calculate this probability of Y winning in 4th match. So it will be this P4 for Y, and in this we need to interchange A and B. So we can write C square. Now here value of n, it should be 3. So it will be this 3 B square plus 6b, and then we'll interchange C with A. So it will be this A. We'll take 3b common. So it will be this 3bc square, and then here will be this b plus 2a, and that's your option A. Now we look at this option 3. Now option 3 is probability that X wins the match. Now X is going to win the match when the value of n varies from 2 to infinite. So this probability that X wins the match will be this probability n varies from 1 to infinite Pn plus 1, which is A square into this summation n varies from 1 to infinite n B to the power of n minus 1 plus A square C into this summation n varies from 1 to infinite n minus 1 B to the power of n minus 2. Now we have to calculate the sum of these two series, this one and this one. Now if we look at the series, which is 1 plus b square up to infinite, we know that this is 1 upon 1 minus b or we can write this as summation b to the power n, where n varies from 0 to infinite. It is 1 upon 1 minus b. Now we differentiate this both sides with respect to b. We'll get this summation. Now n varies from 1 to infinite, n b to the power of n minus 1, and here it will be 1 upon 1 minus b square. So this expression for the first series will be a square upon 1 minus b square. Now here it is a square c. Now we'll differentiate it again. Now if we differentiate this again, we'll get this as n varies from 1 to infinite, n minus 1, b to the power of n minus 2, and here it will be 2 upon 1 minus b cube. So it will be this 2a square c upon 1 minus b cube. Let me simplify this. We can write this as 1 minus b cube, and then it will be this a square into 1 minus b plus 2 into a square c. Now 1 minus b is actually a plus c. So we can write this as a square a plus c plus 2a square c, and here will be this a plus c whole cube. Now we can take a square common, so it will be this a square, and then it will be a plus 3c upon a plus c whole cube, which is your option B. Now the next one is the probability that y wins the match. Now we know that situation for x and y is exactly same, except for a and c must be interchanged. So if we interchange a and c, we'll get this as c cube plus 3c square a upon a plus c cube. That means this option B, it should be correct. And then finally, we need to find the probability that there is no winner. Now, if we add these two cases, then it will be a cube plus c cube plus 3a square c, 3ca square, which is a plus c whole cube. So sum of these two probabilities is 1. So that means these two probabilities, they are mutually exclusive and exhaustive. So out of x and y, there will be exactly one winner. So probability that there will be no winner is simply 0, and that's your option D. Now here the question is, Mr. A randomly picks 3 distinct numbers from the set 1, 2, 3, 4 up to 9 and arranges them in descending order to form a 3-digit number, and Mr. B randomly picks 3 distinct numbers from the set 1, 2, 3, 4, 5, 6, 7, 8 and also arranges them in descending order to form a 3-digit number. Now the first question is, find the probability that Mr. A's 3-digit number is always greater than Mr. B's 3-digit number. Now this first case, this number has to be always greater. Now difference between this set and this set is, this set has 9. So if 9 is chosen by Mr. A in one of the 3 numbers, then in that case, number formed by Mr. A will always be greater than number formed by Mr. B. Now in how many ways 9 can be selected? So we need 3 numbers, out of which 1 is already selected. So from the remaining 8, we have to select any 2, divide by 9C3. Now this is 8, 7, 2, and this is 9, 8, 7, and this is 3 into 2. Now 8, 7 will cancel, 2 will cancel. So this probability is 1 by 3. So there is this 1/3 probability that Mr. A's 3-digit number is always greater than Mr. B's 3-digit number. Now the second question is the probability that A and B has the same 3-digit number. Now for the second part, they'll have same 3-digit number if Mr. A picks 3 numbers from 1 to 8 and Mr. B also picks number from 1 to 8. Now for this, A must not pick 9. The probability that A is going to pick 9 is 1 by 3. Then the probability that A will not pick 9 will be 2 by 3. Now we have 8 numbers available to both, and from these 8 we have to select any 3. It can be done in 8C3 ways. Now Mr. B, it must choose the same number, so it will be simply 3C3 divided by 8C3 and 8C3. I'll cancel. Now this is 2 by 3 and this is 1, and 8C3 is 56, 28, 84. So this probability is 1 by 84. Another way of doing it can be, for Mr. A, he must choose any one out of 8. So it will be this 8C3 divided by 9C3, and B must choose any one. So it will be 1 upon 8C3. Now this will cancel. So it is 1, and this is 9, 8, 7. This is 3 into 2. Now this is 3. This is 4. 12. 12 into 7 is 1 by 84. Now we'll come to this third case when we have Mr. A's number should be larger than Mr. B's number. Now there are two cases. Case 1, if Mr. A's number start with 9. So if Mr. A's number starts with 9, then in that case it will always be greater than that of B's number, and this we have already calculated in part 1. So in this case, this probability that Mr. A's number will be 9, this is 1 by 3. Now if we consider the second case when Mr. A's number doesn't start with 9. Now here we have three cases. Case 1, either A's number will be greater than B's number, or both of them they'll choose the same number, or B's number will be greater than A's number. From symmetry we can say that number of elements in this first case will be same as number of elements in this second case. Now the probability that they'll choose the same number provided the number doesn't start with 9, it will be this 1 by 56, because we have not yet taken the case 2 by 3. So it will be this 1 by 56. So the probability that A chooses a number greater than B, provided A's number doesn't start with 9, it will be 1 minus 1 by 56 divided by 2, because we have equal number of elements in both the cases. Now it will be 55 divided by 112. Now this number is greater than 9 when 8 doesn't choose 9. So the probability that A chooses a number greater than B, if it is not 9, it will be this probability of not choosing 9, which is 2 by 3 into 55 by 112. Now this is 56, that will be 55, 8, 168. Now combining the two probabilities, we get our result that probability A's number will be greater than B will be 1 by 3 plus 55 by 168, and will be 37 by 56, and that's your option A. So the correct options are B, C and A. Now here the question is, a computer producing factory has only two plants, T1 and T2. Plant T1 produces 20% and plant T2 produces 80% of the total computer produced. So we have two plants, T1 and T2. Now plant T1 handles 20% of the production. So this probability of choosing a product from T1, it is 20 by 100, and from T2, this probability will be 80 by 100. If 7% of the computers produced in the factory turns out to be defective, so overall defective will be 7 by 100. It is known that probability computer turns out defective given that product is from plant T1, it is 10 times probability. Computer turns out it is defective, it is produced in plant T2, and suppose this is X. Now first one is probability it is defective if it has come from plant T1, will be X, and probability that it is defective if it has come from plant T2 will be simply X by 10. So from this given information, first we'll find the value of X. Now probability of getting defective will be either we get defective from T1 or we get defective from T2. So it will be this 20X by 100 plus 80X by 1000 and will be equal to 7 by 100. Now this will cancel. So we'll get this as 28X equals 7. Value of X is 1 by 4. So probability of getting a defective from T1, it is 1 by 4, and probability of getting defective from T2, it is 1 by 40. Now it says a computer produced in the factory is randomly selected and it does not turn out to be defective. Find the probability that it is produced in plant T2. Now for this, first we'll calculate this probability, which is probability it is not defective if it has come from T1. Now we know that probability of A upon B plus probability of A naught upon B, it is equal to 1. So probability of D naught upon T1 will be simply 3 by 4 and probability of D naught upon T2 will be 39 by 40. So now again we have two plants, T1 and T2. Getting it from T1, it is 20 by 100, T2 is 80 by 100. Not defective from T1, it is 3 by 4. Not defective from T2, it is 39 by 40. Now, if it is non-defective, find the probability that it has come from T2. So we have to find this conditional probability that if it is not defective, it has come from T2. So we'll take this case in the numerator. So it will be this 80 by 100 into 39 by 40 divided by this 20 by 100 into 3 by 4 plus 80 by 100 into 39 by 40. Now this 0 0 will cancel. We'll cancel this 400. So it will be this 8 into 39 upon 60 plus 8 into 39, which is 312 upon 372, which is 26 by 31. So it is 26 by 31, or if we multiply it with 3, we'll get this as 78 upon 93, and that's your option C. Now here the question is, a signal which can be green or red with probability 4 by 5 and 1 by 5 is received by station A and then transmitted to station B. The probability that each station receiving the signal correctly is 3 by 4. If the signal received at station B was green, find the probability that original signal was also green. Now this signal, it can be either green or red. Now it is green with the probability 4 by 5 and it is red with the probability 1 by 5. Now this green signal, it can be received at station A as either green or red. In the same way, this red signal also can be received as either red or green. Now it will be received green if it received the signal correctly. So it will be this 3 by 4 and here will be this 1 by 4 and red as red again is 3 by 4 and red as green as 1 by 4. Now it says at station B the signal received is green. So at B it will be green if it is received correctly. So it will be this 3 by 4. Now red will be received as green if it is 1 by 4 Now red as green, this is 1 by 4, and green as green, it will be simply 3 by 4. That is given that the signal received at station B is green. We need to find this probability that original signal was green. So we have to take this case in the numerator and all of the cases in the denominator, and that's how we'll get this probability. So this probability will be 4 by 5 into 3 by 4 into 3 by 4 plus 4 by 5 into 1 by 4 into 1 by 4 divided by 4 by 5 into 3 by 4 into 3 by 4 plus 4 by 5 1 by 4 1 by 4 plus 1 by 5 3 by 4 1 by 4 plus 1 by 5 1 by 4 into 3 by 4. Now all these denominators, they'll get cancelled. So this probability will be 36 plus 4 divided by 36 plus 4 plus 3 plus 3. Now this is 40 divided by 46, which is 20 by 23, and that's your option C. Now here the question is, let A1, A2, A3, A21 be the 21 vertices of a regular polygon of 21 sides inscribed in a circle with center O. So we have this circle with center O, and then we have these 21 vertices inscribed. So it is A1, A2, A3 up to A21, and they are all vertices of a regular polygon. Now triangles are formed by joining vertices of this regular polygon. Now total number of triangles that can be formed, it is given by 21C3, and 21C3 is 21 into 20 into 90 divided by 3 into 2. Now this is 7 and this is 10, so it will be 1330. So total number of triangles that can be formed is 1330. Now we need to find the probability that chosen triangle is equilateral triangle. So this first question is that the chosen triangle is an equilateral triangle. Now it will be an equilateral triangle if number of vertices between the three chosen vertices is same. So that means in that case x1 must be equal to x2 and it must be equal to x3. Now sum of all x1, x2, x3 will be 21 minus 3, 18, and since it is 3x1, so each of xi, it must be 6. So we have this combination like a1, a8, a15, and we'll go all the way from a1 to a7, a7, a14, and a21. So altogether we have 7 cases in which an equilateral triangle is formed. So this required probability will be 7 upon 1330, which is basically 1 by 190, and that's your option C. Now we know that angle in a semicircle is 90 degrees. So if there is a right angle triangle, then one of the sides must be diameter of this circle. But since we have 21 vertices, that means if we choose any one vertex opposite to A1, there won't be any vertex. So there will be vertices on the either side of it. In this case, it is not possible to choose a right angle triangle. So probability of choosing a right angle triangle will be simply 0. Now we have to find the probability that chosen triangle is an acute angle triangle. Now what we'll do is we'll actually calculate an obtuse angle triangle, and we'll find how many obtuse angle triangles are possible. Now if we choose one vertex, say A1, then there'll be 10 vertices here and 10 vertices here. Now, number of obtuse angle triangles that can be formed having one of the vertices with A1, it will be 2 into 10C2, which is 90. Now we have 21 such vertices. So total number of obtuse angle triangles that can be formed will be 21 into 90 divided by 2. Why divided by 2? Because if we have one case where we have, suppose, A1, A2 and A7, then if we consider A7, there also we'll have this case when we'll have A1, A2 and A7. With A2 it is not possible because for A2, A1 and A7, they lie on the opposite side. So therefore we have to divide it by 2. So it will be this 21 into 45, which is 945. So now we can find number of acute angle triangles. So number of acute angle triangles will be 1330 minus 945. It will be simply 385. So this required probability that this triangle is acute will be given by 385 upon 1330, which is 11 by 38, and that's your option A. So the correct options are C, D and A, and that is the answer to this question. Now here the question is, three randomly chosen non-negative integers x, y and z are found to satisfy the equation x plus y plus z equals 10. Then the probability that z is even is. Now first we have to find number of total ways of choosing x, y and z. Now this is nothing but this is number of non-negative integral solutions. Non-negative integral solutions for this equation. Now number of non-negative integral solutions for this equation is given by n plus r minus 1 c r minus 1, which is nothing but 12c2, and 12c2 is 66. So there are 66 ways to choose the values of x, y and z. Now we have to find our favorable case in which z is an even number. Now if z is even, we'll say let z is of the form 2k, where the value of k varies from 0 to 5. So we can write x plus y equals 10 minus 2k. Now if we find number of non-negative integral solutions is given by n plus r minus 1 c r minus 1, which in this case will be 11 minus 2k c1, and that is 11 minus 2k. Now these solutions, they vary from range 1 to 5. So total number of favorable cases will be given by this summation k varies from 0 to 5 sk, and will be this summation k varies from 0 to 5 11 minus 2k. Now this is 11 plus 9 plus 7 plus 5 plus 3 and plus 1, which is sum of first 6 odd natural numbers, and sum of first 6 odd natural numbers is simply 6 square, which is 36. So this required probability will be 36 divided by 66, which is 6 by 11, option B. Now here the question is, 12 identical balls are to be placed in 3 identical boxes. Find the probability that one of the boxes contains exactly 3 balls. Since the balls and boxes, they are identical, it's just a problem of partitioning. So we have to partition this 12 in 3 parts. Now it can be done as 12 0 0 or 11 1 0 or 10 2 0 or 10 1 1, 9 3 0 921, 840, 831, 822, 750, 732, 741, 660, 615, 624, and 633. Now with 5, it will be 552, there will be 543, and finally it will be this 4, 4, and 4. So altogether we have 9 and 10, 19 cases. So there will be these 19 cases in which we can distribute these 12 identical balls in 3 identical boxes. Now we have to find the probability that one of the boxes contains exactly 3 balls. Now here we have 3, here we have 3, here also we have 3, here we have 3, and here also we have 3. Now this language is not exactly clear. Now when it says one of the boxes contains exactly 3 balls, so does that mean out of the 3 boxes there is only one which contains exactly 3? So if that is the case, then we'll discard this. So this probability will be 4 by 19 if 2 boxes cannot have 3, 3. And if it is 3 balls in at least one of the boxes, then in that case this probability will be 5 by 19 and it doesn't match any of the options. This question, it should not be 12 identical balls in 3 identical boxes. So what else it could be? Now we can take 12 identical balls in 3 distinct boxes. Now suppose we have 3 boxes, box 1, box 2 and box 3. Suppose we have x1, x2 and x3 number of balls in this. Then here we'll have x1 plus x2 plus x3. It must be equal to 12. So total number of ways of distributing these 12 balls in 3 distinct boxes will be n plus r minus 1 c r minus 1, and there will be 14 c2, which is 91. So that's our total cases. Now we have to find the favorable cases in which one of the boxes contains exactly 3 balls. Now suppose x1 is 3. Now if x1 is 3, then we get x2 plus x3 equals 9. Now solution to this is 9 plus 2 minus 1, c 2 minus 1, which is simply 10. Now in these 10 cases, we have this one case when he'll be this 3, 3 and 6, and this one case when he'll be 3, 6 and 3. So what we'll do is we'll discard these 2 cases. So then we have 8. So it'll be 8 cases when x1 is 3. In the same way, for x2 equals 3, we'll have 8 cases. And for x3 equals 3, we'll again have 8 cases. So this required probability when exactly one of the box contains 3 balls, it will be 24 by 91. But if the question is at least one of the box contains exactly 3 balls, then in that case we have to include all these 6 cases, and in these 6 cases 3 of them, they are repetitions. So in that case this probability will be 24 plus 3, 27 by 91. So this is also noted. Now if it is 12 distinct in 3 identical boxes, then it's a distribution problem, which is very lengthy to calculate. So I won't calculate that one. So now I'll consider this case when we have 12 distinct balls which are to be placed in 3 distinct boxes. So now we have 12 distinct balls which are to be placed in 3 distinct boxes. Now for each ball, we have 3 choices. So total number of ways of distributing these 12 balls in 3 boxes will be 3 into 3 into 3, 12 times, and that will be 3 to the power 12. Now the condition is one of the box contains exactly 3 balls. Now first we'll calculate which box contains these 3 balls. So it will be 3C1. Now in this box we have to select 3 balls from 12 distinct balls, which can be done in 12C 3 ways. Now we are left with 9 balls and 2 boxes. Now these 9 balls, they are to be distributed in these 2 boxes. Now if we consider the case when at least one of the boxes has 3 balls, then for each of the 9 balls we have 2 choices. So it can be distributed in remaining 2 boxes in 2 to the power 9 ways. So in this case, this required property will be 3 and then 12, 11, 10, 3 to 2 to the power 9 upon 3 to the power 12. Now this 3 will cancel. This is 5. Now this is 3 to the power 11 and this is 2 to the power 11. So we'll write this as 55 into 2 by 3 to the power 11, which again doesn't match with any option. Another question is exactly one of them should contain 3 balls. In that case, from these 2 to the power 9 cases, we have to remove all those cases in which we have distributed them as 3 and 6. Now we can write this as factorial 9, factorial 3, factorial 6, and then it will be multiplied with factorial 2. In that case, this property will be 3C1 into 12C3 to the power 9 minus 2 into 9C3 divided by 3 to the power 12. Now here the question is, Mr. B has 2 fair 6-sided dice, one of whose faces are numbered from 1 to 6 and the second one whose faces are numbered 3 to 8. Twice he randomly picks one of the dice and rolls it. Given that sum of the resulting 2 rolls is 9, find the probability that he rolled the same dice twice is. Now there are 3 possibilities. Either he can roll this first die, which is say D1 twice. So it will be this D1 D1, or it could be D1 D2 or D2 D1, or it could be D2 D2. Now probability of choosing first die, it is 1 by 2, and choosing it again is 1 by 2. So it will be this 1 by 4. This probability is also 1 by 4. Now this is 2 times 1 by 4. So it will be 1 by 2. So these 3, they are mutually exclusive and exhaustive cases. Now if he has thrown this regular die both times, then the sum could be 9 if it is 3, 6, 4, 5, 5, 4 and 6, 3. In that case, this probability will be 4 by 36. Now if it is D1, D2, then it could be 1, 8, 2, 7, 3, 6, 4, 5, 5, 4 and 6, 3. So there will be 6 cases. So then it will be this 6 by 36. And if it is both D2, then we'll have 3, 6, 4, 5, 5, 4 and 6, 3. So again, it will be this 4 by 36. Now we need to find the probability that he rolled same dice twice. So that means either this case or this case. Now it's a Bayes theorem question. So this probability will be this 1 by 4 into 4 by 36 plus 1 by 4 into 4 by 36 divided by 1 by 4 into 4 by 36 plus 1 by 4 into 4 by 36 plus 1 by 2 into 6 by 36. Now this 4 will cancel. Now this is 3 and this 36 will also cancel. So this probability will actually be 2 by 5. And that's the value of m and n. Now we need to find the value of m plus n. So this m plus n will be simply 7, and that is the answer to this question. 3 A's, 3 B's and 3 C's are placed randomly in a 3 cross 3 matrix. So if we have a 3 cross 3 matrix, then we have 9 positions, and in these 9 positions we have to arrange 3 A's, 3 B's and 3 C's. Now total number of ways of doing it will be factorial 9 divided by factorial 3 and factorial 3. Now it says find the probability that no row or column contain 2 identical letters. Now there will be no row or column containing 2 identical letters if it is of the form ABC, BCA and CAB. Now we can arrange these 3 rows in factorial 3 different ways. So there will be 6 ways in which we get different matrices. We can also arrange them along the columns. So again it will be this factorial 3, that is 6. So favorable number of cases where no row or column will contain 2 identical letters is 12. So this required probability will be 12 upon factorial 9, factorial 3, factorial 3, factorial 3. Now this is 9, 8, 7, 6, 5, 4, 3, 2. Now this 6 will cancel. 36 will also cancel. Now this is 6, 2 and 4. So this probability will be 1 by 140. Now it is of the form P by Q. So the value of P plus Q is 141, and that's your option C. Now here the question is, a set contains 3 n members. Let P n be the probability that S is partitioned into 3 disjoint subsets with n members in each subset, such that the 3 largest members of S are in different subsets. Then we need to find this limit n tends to infinite Pn. Now first we'll find total number of ways of distributing these 3 n members in 3 subsets. Now it can be done in factorial 3n divided by factorial n, factorial n, factorial n 3 times. And since we are partitioning it, these 3 subsets, they are identical. So that is a total number of ways of partitioning this set. Now for favorable cases, we have 3 largest members of S. Now suppose there are L1, L2 and L3. Now we are left with 3 n minus 3 members which are to be distributed in n minus 1, n minus 1 and n minus 1 ways. Now it can be done in 3n minus 3 factorial upon n minus 1 whole cube divided by factorial 3. Now in this case, since we have 3 different people, so we can arrange these 3 groups in factorial 3 ways. So this, for this favorable, this factorial 3 will cancel. So this required probability Pn will be factorial 3n minus 3 upon n minus 1 factorial cube divided by factorial 3n factorial n cube into factorial 3. Now it will be this 6n cube, and here will be this 3n minus 1 and 3n minus 2. Now this 3n will cancel, so we get 2n square. Now we take this limit n tends to infinite. Here coefficient of n square is 2 and the denominator coefficient of n square is 9. So answer to this limit is 2 by 9, and that's your option D. Now here the question is, for 2 events A and B, probability of A is 3 by 5 and probability of D is 2 by 3, then which of the following is or are correct? Now we know that P A union B will be greater than or equal to maximum of P and PB because it is a superset, which in this case is 2 by 3. That means probability of A union B will always be greater than or equal to 2 by 3. Now we also know that any probability is always less than or equal to 1. So this value will always lie between 2 by 3 and 1. Now if we look at probability of A intersection B will be PA plus PB minus PA union B. Now if we look at PA plus PB, it will be 9 plus 10, 19 by 15 minus P A union B. Now we'll get this minimum value when P A union B is maximum and maximum value of P A union B is 1. So 19 by 15 minus 1 will be simply 4 by 15. So P A union B minimum value will be 4 by 15 and we'll get its maximum value when A union B is minimum, which is 2 by 3. So 19 by 15 minus 2 by 3 will be simply 9 by 15, which is 3 by 5. So that means this option C is also correct. Now we look at probability of A intersection B naught. Now probability of A intersection B naught is probability of A minus probability of A intersection B. Now probability of A is 3 by 5 minus probability of A intersection B. Now we are looking for its maximum value. Its value will be maximum when value of A intersection B is minimum. So P A intersection B naught will always be less than or equal to 3 by 5 minus 4 by 15, which is 5 by 15, that is 1 by 3. That means this option A is also correct. Now if we look at this option D is probability of A naught upon B. Now probability of A naught upon B is probability of A naught intersection B upon probability of B, or will be this probability of B minus probability of A intersection B upon probability of B. So it will be 1 minus, now P intersection B will work out and probability of B is 2 by 3. So it will be this 3 by 2 into probability of A intersection B. Now if we look at its maximum value, in that case we have to look for minimum value of A intersection B, and minimum value of A intersection B is 4 by 15. So it will be into 4 by 15, so which is 2 by 5. So it will be 3 by 5. So its maximum value is 3 by 5, and for minimum we'll put this as 3 by 5. So there will be 9 by 10, and 1 minus 9 by 10 is 1 by 10. So its minimum value will be 1 by 10. That means this option D is also correct. So all the 4 options are correct for this question. Now here the question is, let EC denote the complement of an event and let E, F and G be pairwise independent events such that PG is greater than 0 and probability of E intersection F intersection G is equal to 0. Then we need to find this probability that E naught intersection F naught upon G. Now we can write this as probability of G intersection E naught intersection F naught divided by probability of G. Now if we look at this Venn diagram of G, E and F, that means we are looking at the portion of G which is common to E naught and F naught. So we are talking about this region. Now this region, it is given by probability of G minus probability of G intersection E minus probability of G intersection F and plus probability of G intersection E intersection F divided by probability of G. Now probability of E intersection F intersection G, it is 0. Now we can write this as probability of G. Now since E, F and G are pairwise independent, so we can write this as probability of G into probability of E minus probability of G into probability of F divided by probability of G. Now this probability of G will cancel, so we can write this as 1 minus probability of E minus probability of F. Now we can write this as either PE dash minus PF or PF dash minus PE. So it will be this option C. Now here the question is, an experiment has 10 equally likely outcomes. Let A and B be non-empty events of the experiment. Now A consists of 4 outcomes. The number of outcomes that B must have so that A and B are independent is. Now probability of A, it is 4 by 10. Probability of B is, now suppose B has B outcomes, so this probability will be simply B by 10, and suppose A intersection B, it is C, which is common. So probability of A intersection B is C by 10, and this C, it is less than or equal to minimum of B and 4. Now if they are independent, then P A intersection B is equal to PA into PB. That means C by 10 will be equal to 4B by 100, or we can write 2B must be equal to 5C, or B should be equal to 5C by 2. Now since B is non-empty, the value of C cannot be 0, but C has to be an even number. So the only possible values of C in this case are either C can be 2 or C can be 4. Now if C is 2, then the value of B is 5, and if C is 4, then the value of B is 10. So B must have either 5 or 10 outcomes. That means this option D is correct. Now here it says, at a telephone inquiry system, the number of phone calls regarding relevant inquiry follows Poisson's distribution with an average of 5 phone calls during 10-minute time interval. So in this case, its mean is 5. So we'll take lambda is 5. Now we know that in Poisson's distribution, probability of x equals x is given by e to the power minus lambda into lambda to the power x upon factorial x, where x varies from 0 to infinite and it takes discrete integral values. Now we need to find the probability that there is at the most one phone call. That means we have to find this probability that x is less than or equal to 1. Now this is probability of x equal to 0 plus probability of x equal to 1. Now here value of lambda is 5. So it will be e to the power minus 5 lambda to the power 0 upon factorial 0 plus e to the power minus 5 into 5 to the power 1 upon factorial 1. So it will be simply 6 upon e to the power 5, and that's your option D. Now here we are given that Px upon y is 1 upon 2. So probability of x intersection y upon probability of y, it is 1 by 2. Probability of y upon x, which is probability of x intersection y upon probability of x, it is 1 by 3, and probability of x intersection y is 1 by 6. Now using these three, we can calculate Px and Py. Now this Px will be 1 by 2 and Py will be 1 by 3. Now once we have Px, Py and Px intersection y, we can calculate Px union y. Now it will be 1 by 2 plus 1 by 3 minus 1 by 6. So there will be 4 by 6, which is 2 by 3. That means this statement A is correct. Now px into py, this is 1 by 6, which is same as px intersection y. That means x and y are independent, and if they are independent, c is incorrect. Now we need to find probability of xc intersection y. Now since they are independent, we can write this as pxc into py. Now px naught is 1 by 2 and py is 1 by 3. That means this option D is also incorrect. So the correct options are A and B. Now here the question is, let U1 and U2 be two urns such that U1 contains 3 white and 2 red balls and U2 contains only 1 white ball. Now a fair coin is tossed. If head appears, then 1 ball is drawn at random from urn 1 and put into urn 2. And if tail appears, then 2 balls are drawn at random from U1 and put into U2. Now 1 ball is drawn at random from U2. The probability of the drawn ball from U2 being white is. Now what we'll do is, first we'll toss a coin and it will result in either heads or tail. So probability of getting a heads is 1 by 2 and probability of getting a tail is 1 by 2. Now if it is head, then 1 ball is drawn at random from U1 and put into U2. So this 1 ball, it could be either white or red. Now probability of getting a white ball, it is 3 by 5 and red ball is 2 by 5. Now if it is head, U2 will have 2 white now, and if it is red, it will have 1 white and 1 red. Now 1 ball is drawn from U2. We need to find the probability that drawn ball is white. Now if it is 2 white, then probability of drawing a white ball, it is 1. And if it is 1 white and 1 red, this probability will be 1 by 2. Now if the coin results in tail, then we have 3 choices. Either the transferred balls will be 2 white or 2 red or 1 white and 1 red. Now probability of choosing 2 white will be 3c2 upon 5c2. It will be 3 by 10. Now 2 red, 2c2 upon 5c2, 1 by 10, and 1 white and 1 red, there will be 3c1 into 2c1, which is 6 by 10. Now if it is 2 white, urn 2 will have 3 white now, or it will have 1 white and 2 red, or it will have 2 white and 1 red. Now probability of getting a white ball, here in this case is 1, here will be this 1 by 3, and here will be this 2 by 3. Now first we need to find the probability that white ball is being drawn from. So probability that it is a white ball which is drawn from U2. Now basically it's a conditional probability, so we have to multiply all these probabilities. So it will be this 1 by 2 into 3 by 5 into 1 plus 1 by 2 into 2 by 5 into 1 by 2 plus 1 by 2 into 3 by 10 into 1 plus 1 by 2 into 1 by 10 into 1 by 3 plus 1 by 2 into 6 by 10 into 2 by 3. Now this is 3 by 10 plus 1 by 10 plus 3 by 20, 1 by 60, 2 by 10. Now this is 6 by 10, 36 by 60, 9 by 60 plus 1 by 60, which is 46 by 60. Now this is 23 by 30, and that's your option B. Now the second part is, given that the drawn ball from U2 is white, the probability that head appeared on the coin is. Now this is Bayes' theorem. So you have to find if it is a white ball, then head appeared on the coin. So this case of heads, it should be in the numerator, and this total probability will be in the denominator. Now this probability of heads, it is these first two terms, which is 4 by 10. So it will be 4 by 10 divided by 23 by 30. So it will be simply 12 by 23, and that's your option D. Now here the question is, if A, B, C are natural numbers, then the probability that A square plus B square plus C square is divisible by 7 is m by n, then m plus n is equal to. Now we know that we can write any number as 7m plus r whole square, and 7m plus r whole square, it is r square remainder r dash modulo 7, where r, it takes the value from 0 to 6. Now when r square is 0, it is 0 modulo 7. If it is 1, it is 1 modulo 7. 2 square is 4 modulo 7. 3 square 9. 9 is 2 modulo 7. 4 square is 16, which again is 2 modulo 7. 5 square is 4 modulo 7. And 6 square is 1 modulo 7. These are the possible remainders for 7m plus r, where r can take these 7 values. Now it says we need to find the probability that a square plus b square plus c square is divisible by 7. Now it will be divisible by 7 if all of them, they are 0 modulo 7. That is this case, or when it is 1, 2 and 4. So in that case, it will be 1 plus 2 plus 4, 7, which again is 0 modulo 7. So sum of these three squares, they will be divisible by 7 in these two cases. For A to have 0 modulo 7, it should be 7m plus 0. So value of r, it should be 0. So in that case, this probability is 1 by 7. Now for B also, it will be 1 by 7, and for C also, it will be 1 by 7. So for this first case, this required probability will be 1 by 7 cube. Now for this second case, modulo 1, we have two cases. So there will be 2 by 7. Modulo 2 is again two cases. So there will be 2 by 7. And modulo 4 is also two cases. So there will be 2 by 7. And out of these A, B and C, anyone can have 1, 2 and 4. So we can distribute it in factorial 3 ways. So it will be 48 upon 7 cube. So this required probability is sum of these two, which is 49 by 7 cube, which is nothing but 1 by 7, and that's your m by n. Now the value of m plus n is simply 8. So answer to this question is 8. Now the question is, a person throws 2 fair dice. He wins rupees 15 for throwing a doublet, wins 12 when he throws a result in the sum of 9, and loses 6 for any other outcome of the throw. We need to find expected gain or loss of this person. So here we have 3 values for random variable. So either it will be plus 15 or plus 12, or it will be this minus 6. Now what are their probabilities? Now he'll get 15 when he throws a doublet, and this probability is 6 by 36. Now he'll get rupees 12 if the sum is 9. So it'll be 9 if it is 3, 6, 4, 5, 5, 4 and 6, 3, which is 4 by 36, and all other cases it is minus 6. So it'll be this 10 by 36. 1 minus 10 by 36 is 26 by 36. Now expected value of x will be 15 into 3 plus 12 into 2 minus 6 into 13 whole divided by 18, which is minus 1 by 2. So the expected gain of this person is minus 1 by 2 loss. Now here the question is, we have this set S, a subset B is said to be nice if sum of elements of B is 2, 0, 3. Now if we look at sum of all elements in S, it will be 1 plus 2 up to 20, and there will be n plus 1 by 2, and there will be 210. Now this sum will be nice if it is 203. That means we have to subtract 7 from this. Now in how many ways you can subtract 7? So it could be this 7 itself, or it could be this 1, 6, or 2, 5, 3, 4, or it could be this 1, 2, 4. So these are the 5 possible cases where we can leave out 7 from the sum. So the probability that this sum is nice, it will be 5 divided by a total number of subsets that can be formed is 2 into 2 into 2, 20 times. So that will be 2 to the power 20, and that's your option D. Now here the question, in a game, man wins 100 if he gets 5 or 6 on a throw of fair die and loses 50 for getting any other number on the die. If he decides to throw the die either till he gets a 5 or a 6 or to a maximum of 3 throws, then his expected gain or loss in rupees is. Now probability of his winning is only if he gets 5 or 6. So this probability is 2 by 6, which is 1 by 3, and probability of him losing on any chances 2 by 3. Now this game continues if he gets P, or if it is QP, or if it is QQP, or if it is Q, Q and Q. Now in this case, value of a random variable will be, if he wins, it will be 100. So it will be this 100. Now there is a loss and a win. So it will be 100 minus 50. So it will be plus 50. Now 2 losses and 1 win. So value of x is 0. And then 3 losses will be minus 150. And their respective probabilities, they are 1 by 3. Now this is 2 by 9. This is 4 by 27. And this is 8 by 27. So expected value of this random variable x will be 100 by 3 plus 100 by 9 minus 1200 by 27. Now this is 900 by 27 plus 300 by 27 minus 1200 by 27, which is 0. So expected value is 0. No gain, no loss. Here the question is, there are 3 different pair of shoes in a lot. Now 3 persons come and pick the shoes randomly. Let P be the probability that no one is able to wear shoes. We need to find the value of 13 P upon 4 minus P. Now let us say there are 3 people, P, Q and R. What we'll do is, we'll find the probability that at least one of them gets a matching pair. So we'll find this probability that at least one of P, Q or R gets a matching pair. So now this is this summation probability, one of them gets it, minus this probability 2 of them gets a matching pair, and plus this probability all of them they get the matching pair. Now probability that P gets a matching pair, it is 3C1 divided by 6C2. Now this is 3 and this is 3 into 5. So it will be this 1 by 5 and will be same for Q and R. So this will be simply 3 by 5. Now both P and Q, they get correct pair. So this probability P intersection Q. Now P chooses correct pair, so it is 1 by 5, and then Q also chooses the correct pair. Now Q chooses the correct pair. That means it should be 2C1 from 4C2. So it will be this 1 by 5 and then 2 and 3. So it will be this 1 by 15. So it should be this 3 into 1 by 15. And this third one is automatically same as 1 by 15. So basically this probability is 7 by 15. Now we need to find the probability that none of them gets a matching pair. So this probability will be complement of this given probability. So it will be 1 minus 7 by 15 and that is 8 by 15. Now once we have the value of P, we can calculate this expression. So it will be this 13 into 8 by 15 and 4 minus 8 by 15. So it will be this 13 into 8 and this is 60. 60 minus 8 is 52. Now this is 4 and 2. So answer to this question is simply 2. Now here the question is, there are 8 seats in the front row of a theatre in which 4 persons are to be seated. Then the probability of seating them so that no 2 persons are side by side. Now for this we need to select 4 chairs which are separate from each other. So basically this is nothing but this is non-consecutive selection. Now we have already studied non-consecutive selections in a row in one of the previous videos, and we know that if we have n objects and out of which we have to select k objects which are not consecutive, then it can be done in n minus k plus 1 c k ways. Now in this, value of n is 8 and value of k is 4. So total number of ways of choosing 4 seats so that none of them is side by side, it will be given by 8 minus 4 plus 1 c4, which is basically 5c4. So we can select these 4 non-consecutive seats in 5 ways. Now in these selected 4 seats, these 4 people, they can be arranged in factorial 4 ways. Now we need to find this probability. So it will be this 5 into factorial 4 divided by total number of ways. Total number is any 4 out of 8 into factorial 4. Now this factorial 4 will cancel. So this is 5 and this is 8, 7, 6, 5 and this is 4, 3, 2 and 1. Now 5 and 5 will cancel. Now this is 8. So this value is simply 1 by 14. So the probability that no 2 persons sit side by side is 1 by 14 and that's your option A. Now the next one is each person has exactly one neighbor. Now when each person has exactly one neighbor, that means 2 of them, they are sitting together. Another 2, they are sitting together. And in between them, there should be at least 1. So suppose there are x1 seats here, x2 seats here and x3 seats here. So we write x1 plus x2 plus x3. It must be equal to 4, where x1 and x3, they are greater than or equal to 0 and x2 is greater than or equal to 1. Now we'll replace x2 with 1 plus x2 dash. So we can write this as x1 plus x2 dash plus x3. It is equal to 3, where each of xi or xi dash, it is greater than or equal to 0. That means we need to find number of non-negative integral solutions. So number of non-negative integral solutions is given by n plus r minus 1 and that is simply 10. Now we have 4 places here. Now in these 4 places, we can arrange these 4 people in factorial 4 ways and then total number of ways of selecting these 2 and 2 seats will be 10 divided by total number of ways of arrangement, which is 8c4 into factorial 4. Now this factorial 4 will cancel. Now this is 10 and this is 8 7, 6, 5, and this is 4, 3, 2, 1. Now 4, and this is 2. So this probability is nothing but simply 1 by 7, and that's your option C. Now this third part of the question is all of them sit together in a row, avoiding 2 end seeds. So we have 8 seeds, 1, 2, 3, 4, 5, 6, 7, and 8. So this is 1, 2, 3, 4, 5, 6, 7, and 8. Now we have to avoid this first seed and this 8th seed. Now all of them, they can sit in either 2, 3, 4, 5, 3, 4, 5, 6, and 4, 5, 6, and 7. So we have 3 choices. And then in the 4 consecutive, we can arrange them in factorial 4 ways. Divide by 8C4 into factorial 4. Now this factorial 4 will cancel. Now this is 3. Now this is 8, 7, 6, 5, 4, 3, 2, 1. Now this is 8. Now this is 2. So it will be this 3 by 70, and that's your option B. Now here the question is, of the 3 independent events E1, E2 and E3, the probability that only E1 occurs is alpha, only E2 occurs is beta, and only E3 occurs is gamma. Let the probability P that none of the events E1, E2 or E3 occurs satisfy the equation alpha minus 2 beta P equals alpha beta and beta minus 3 gamma into P equals 2 beta gamma. All the given probabilities are assumed to lie in the interval 0 to 1, both not inclusive. Then we need to find probability of occurrence of E1 upon probability of occurrence of E2. Now say probability of occurrence of E1, it is say A, probability of occurrence of E2, it is say B, and probability of occurrence of E3, it is C. Now the first one is only E1 occurs, that is P E1 intersection E2 naught intersection E3 naught. Now they are independent events. So this probability will be A into 1 minus B into 1 minus C, and it is equal to alpha. In the same way we can write 1 minus A into B into 1 minus C will be this beta, and then 1 minus A, 1 minus B into C, and this is gamma. Now we are given that none of E1, E2, E3 occurs. This probability will be 1 minus A, 1 minus B, 1 minus C, and it is equal to P. Now we divide this first with fourth. We can write A upon 1 minus A will be equal to alpha upon P, and if we use component to dividend, we can write A equals alpha upon P plus alpha. In the same way, we'll write B as beta upon P plus beta and C as gamma upon P plus gamma. Now we need to find the value of A upon C. Now A upon C is alpha into P plus gamma upon gamma into P plus alpha. Now we'll get this expression from these two given conditions. So what we'll do is we'll eliminate beta from these. Now from this first one we can write beta equals alpha P upon 2P plus alpha, and from the second one we'll write beta as 3 gamma P upon P minus 2 gamma. Now we equate them, we can write alpha P upon 2P plus alpha will be equal to 3 gamma P upon P minus 2 gamma. Now this P and P will cancel. We'll get alpha P minus 2 alpha gamma will be equal to 6 P gamma plus 3 alpha gamma. Now what we'll do is we'll add 3 alpha gamma both sides. So we can write alpha P plus gamma and it will be equal to 6 gamma P plus alpha. So if we rearrange, we can write alpha P plus gamma upon gamma P plus alpha. It must be equal to 6. So value of probability of E1 upon probability of E3 will be nothing but 6, and that is the answer to this question. Now here the question is, a box B1 contains 1 white, 3 red and 2 black balls. Another box B2, it contains 2 white, 3 red and 4 black balls, and another box B3, it contains 3 white, 4 red and 5 black balls. Now if one ball is drawn from each of the boxes B1, B2 and B3, find the probability that all drawn balls are of same color. Now all the 3 balls, they are of same color if all 3 of them are W. So it will be W, 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 or red, red and red, or black, black and black. Now this probability, now white from this first box, it is 1 by 6. White from second, it is 2 by 9, and white from third, it is 3 by 12. Now if it is all red, then it will be this 3 into 4 divided by 6 into 9 into 12 and plus 2 into 4 into 5 upon 6 into 9 into 12. Now this is 6 plus 36 plus 40 divided by 108 into 6. Now this is 82 upon 648, and that's your option A. Now the second question is, 2 balls are drawn without replacement from a randomly selected box, and one of the ball is white and the other ball is red. The probability that these 2 balls are drawn from box B2. Now this is Bayes theorem question. Now these 2 balls, they may be from box B1 or B2 or B3. Now probability of choosing any one box, it is 1 by 3, 1 by 3 and 1 by 3. Now if we choose B1, then the probability of getting 1 white and 1 red will be 1C1 into 3C1 upon 6C2. Now for second it will be 2C1 into 3C1 upon 9C2, and here it will be 3C1 into 4C1 upon 12C2. Now this is 3 by 15, and 3 by 15 is 1 by 5, and this is 6 by 36, which is 1 by 6, and here it is 12, and this is 6 into 11, which is 2 by 11. Now if this event, say A, it has already occurred, we have to find the probability that the ball is drawn from the box 2. So we have to find P B2 by A. So we'll take this case in the numerator. So it will be this 1 by 3 into 1 by 6 upon all the cases. So this is 1 by 3 into 1 by 5 plus 1 by 3 into 1 by 6 plus 1 by 3 into 2 by 11. Now this 3 will get cancelled. Now this is 1 by 6, and here it is 66 plus 55 plus 60 upon 55 into 6. Now this 6 will cancel. So this value will be 55 upon 126 plus 55, which is 181. And that's your option D. Now here the question is, 3 boys and 2 girls stand in a queue. The probability that number of boys ahead of every girl is at least 1 more than number of girls ahead of her. Now it could be boy, 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 and then the two girls, or it could be boy, boy, girl, boy and girl, or it could be boy, boy, girl, girl and boy, or it will be this boy, girl, boy, girl and boy, or it could be boy, girl, boy, boy and girl. So these are the 5 possibilities. So it should start with boy, because before any girl, number of girls is 0, so it should have at least one boy. All these permutations, they'll start with a boy, and then we have to follow the given condition. Now in each arrangement, we have 3 places for boys and 2 places for girls, and in which they can be arranged in factorial 3 into factorial 2 ways. So total number of ways of arranging them with the given condition will be simply 5 into factorial 3 into factorial 2 divided by total number of ways. Now total number of ways of arranging these 5 people will be simply factorial 5. So this probability will be nothing but 1 by 2, and that's your option A. Now here the question is, A is a set containing n elements. A subset P is selected at random from set A, and set A is then reconstructed by replacing the elements. A subset Q is also chosen, may be void also. The probability that number of elements in P is equal to number of elements in Q. Now total number of ways of choosing P and Q will be, now for P we have 2 choices for each element, so there will be 2 into 2 into 2 n times, and for Q also it will be 2 into 2 into 2 n times. So total number of ways of choosing P and Q will be 4 to the power n. Now this first case is number of elements in P is equal to number of elements in Q. Either both of them, they'll have 0 elements, or 1 element, or 2 elements, up to n elements. Now if they have both 0, then it will be nc0 square, both 1, nc1 square, up to ncn square, and from binomial we know that this is nothing but this is 2ncn. So this required probability will be 2ncn divided by 4 to the power n, which is this option P. So this A, it matches with P. Now the second one is number of elements in P is more than that in Q. Now we'll have 3 cases. Either P will have more elements than Q, or they'll have same number of elements, or number of elements in P is less than number of elements in Q. Now there is no difference between the 2 sets and their conditions. That means number of elements in this case will be same as number of elements in the other case. So if we have to find this probability will be simply 1 by 2, and then 1 minus when they have equal number of elements, which is 2ncn upon 4 to the power n. Now we can write this as 4 to the power n minus 2ncn upon 2 to the power 2n plus 1, which is your option Q. So this B, it matches with Q. Now this third one is P intersection Q is 5. Now if P intersection Q is 5, then for each element we have 3 choices. Either it'll go to P, or it'll go to Q, or it won't go to any of P. So total number of ways of choosing 2 subsets P and Q such that their intersection is 5 will be 3 to the power n, and this probability will be 3 to the power n divided by 4 to the power n, which is your option S. So this C, it matches with S. Now D is Q is a subset of P. Now if Q is a subset of P, then first case is when Q doesn't have any element. So it is NC0. Then in that case, for each element, we have 2 choices. So we can construct this P in 2 to the power n ways. Now if there is 1 element in Q, now that element is already present in P, then for the remaining n minus 1 elements, we'll have 2 to the power n minus 1 choices. And then it will be NC2 2 to the power of n minus 2, and then it will be NCn 2 to the power 0, which is nothing but, which is binomial expansion of 3 to the power n. So favorable cases where Q is a subset of P is 3 to the power n. That means this required probability will be 3 to the power n upon 4 to the power n. So this D, it also matches with S. So A matches with P, B with Q, C with S, and D with S. And that is the answer to this question. Now here the question is, we are given PA, PB, and PC, PA intersection B, and PA intersection C, and PA intersection B intersection C. It says if probability of A union B union C is greater than or equal to 0.75, then show that probability of B intersection C lies in the interval 0.25 to 0.48. Now we know that probability of A union B union C is probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C, which we need to find, minus probability of A intersection C plus probability of A intersection B intersection C, which is 1.23 minus probability of B intersection C. Now we given that probability of A union B union C is always greater than or equal to 0.75, and we also know that any probability is always less than or equal to 1. So this value, it is greater than 0.75 and will always be less than or equal to 1. Now this is minus 0.48 less than or equal to minus B intersection C, and will be less than minus 0.23. Now we multiply it with minus, inequality sign will reverse. So in that case, we'll get this X lying between 0.23 and 0.48, which is what we need to prove in this question. Now the question is, if A, B, C are three events such that probability of B is 3 by 4, A intersection B intersection C naught is 1 by 3, and A naught intersection B intersection C naught is 1 by 3, then probability of B intersection C is. So we have three events A, B, C. So this is A, B, and C. Now we are given that probability of B is 3 by 4. So probability of B is 3 by 4, which is this entire region. Now probability of A intersection B intersection C naught. So that means we are talking about that portion of A intersection B which doesn't contain C. So it is this portion. And this probability is 1 by 3. And probability of B intersection A naught and C naught. So that part of B which doesn't contain A and C. So we are talking about this region. So this probability is 1 by 3. Now we are supposed to find this probability. Now we know that sum of all these three will be equal to PB. So 3 by 4 equals 1 by 3 plus 1 by 3 plus probability of B intersection C. So probability of B intersection C will be 3 by 4 minus 2 by 3, which is 1 by 12, and that's your option A. Now the question is, three numbers are chosen at random without replacement from 1 to 10. The probability that minimum of chosen number is 3 or their maximum is 7. So we have this event A in which minimum is 3 and B is this event when maximum is 7. We have to find probability of A union B. Now probability of A when minimum is 3. So we have one number which is 3, and then we need to choose two numbers which are greater than 3, which can be done in 7C2 ways. So it will be 7C2 upon 10C3. Now probability of B, maximum is 7. So we need to choose 2 from 1 to 6. So it will be 6C2 upon 10C3, and then probability of A intersection B, where we have minimum as 3 and maximum as 7. So in that case, we need to choose 1 from 3. So it will be this 3C1 upon 10C3. So we need to find this probability of A union B, and it will be 7C2, and 7C2 is 21 plus 6C2 is 15 minus 3 upon 10C2, which is 10, 9, 8 upon 3 into 2. So this is 3 and this is 4. So it will be this 120 and this is 12. So it will be this 33 which is basically 11 by 40. So answer to this question is 11 by 40. Now here the question is, consider a function fx equals x cube plus ax square plus bx plus c, where a, b, c are chosen by throwing a die 3 times. Now find the probability that fx is an increasing function. Now you find total number of ways of choosing a, b, c. Now for each of a, b and c we have 6 options. So total will be 6 into 6 into 6, that is 216 times. Now this function has to be an increasing function. Now it will be increasing if f dash x, which is 3x square plus 2ax plus b, it is greater than or equal to 0. Now this is always positive for all x when leading coefficient is positive and when discriminant is less than or equal to 0. So the condition that we have here is 4a square minus 12b should be less than equal to 0, or when a square is less than or equal to 3b. Now we need to choose the values of a and b. Now if we take b as 1, then value of a can be 1. Now if we take b as 2, it will be 6. Now we can take the value 1 and 2. If b is 3, then a can take the value 1, 2 and 3. If b is 4, again it will be 1, 2, 3. If b is 5, again we'll have 1, 2, 3. And if b is 6, value of a will be 1, 2, 3 and 4. So altogether we have these 16 cases, and in each case we can have 6 different values of c. So it will be 16 into 6. So this required probability will be 16 into 6 divided by 216. Now this is 36, which is 4 by 9, and that's your option C. Now here the question is, 2 fair dice, each with faces numbered 1 to 6, are rolled together. The sum of numbers on the face is observed. The process is repeated till the sum is either a prime number or a perfect square. Suppose the sum turns out to be a perfect square before it turns out to be a prime number. If p is the probability that this perfect square is an odd number, then the value of 14p is. Now this sum, it can be a prime number if the sum is either 2, 3, 5, 7 or 11. Now we'll get 2 if we have 1, 1. For 3 it will be 1, 2, 2, 1. For 5 it is 1, 4, 2, 3, 3, 2, 4, 1. 7 is 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1, and 11 is 5, 6 and 6, 5. So we have 5 and 5, 10 and 5, 15. So there are 15 possible cases. So the probability that this sum will be a prime number will be simply 15 by 36. Now it will be a perfect square if the sum is either 4 or 9. Now it will be 4 if it is 1, 3, 2, 2 and 3, 1, and it will be 9 if it is 3, 6, 4, 5, 5, 4 and 6, 3. So probability that this sum, it is a perfect square, it is 7 by 36. Now we have two events. Say this event A, when the sum turns out to be a perfect square before it turns out to be a prime number. So we'll find this probability of A. Now it can be a perfect square on the first row, so it will be this 7 by 36 plus, now we need to get a second attempt, and we'll get a second attempt. So this first attempt, it should not be a prime number and it should not be a perfect square. So this probability will be 1 minus, now 15 plus 7 will be 22 divided by 36, and 22 divided by 36 is 14 by 36. So it will be this 14 by 36, and then on the second attempt we get this as 7 by 36. Now we don't get a perfect square on the first two, we get it on the third, so it will be this 7 by 36, and we'll continue up to infinite. And then we have this event B, that this perfect square is an odd number. Now this perfect square will be an odd number. Then if we look at the probability of A intersection B, that means we get an odd perfect square before it turns out to be a prime number. Now it will be an odd number if we have this sum as 9. So this success will be 4 by 36 plus, now it will be 14 by 36 into 4 by 36, and this series again will continue up to infinite. So this required probability of B, if A has already happened, it will be this GP 4 by 36 plus 14 by 36 into 4 by 36 up to infinite upon 7 by 36 plus 14 by 36 into 7 by 36 up to infinite. Now this is A upon 1 minus R, and this also is A upon 1 minus R. I'll cancel, 36 will also cancel, so this conditional probability will be simply 4 by 7. Now we need to find the value of 14p. So the value of 14p will be simply 8, and that is the answer to this question. Now here the question is, football teams T1 and T2 have to play 2 games against each other. So they have to play 2 games. Now it is assumed that outcome of the 2 games are independent. The probability of T1 winning, drawing and losing, they are 1 by 2, 1 by 6 and 1 by 3. Now each team, they gets 3 points for a win and 1 point for a draw and 0 for a loss. Let X and Y denote total points scored by teams T1 and T2. Now we have to find the probability that X is greater than Y. Now we have this scenario when team 1, it wins both the matches. And in this case, this team, it will have 6 points. T2 will have 0 points. And there could be, there is a win and a draw. Here will be loss and a draw. Now win and a draw is 4 and here it is 1. So in both the cases, X is greater than Y, and these are the only 2 cases possible. Now we'll calculate this probability X is greater than Y. Now if it is 2 wins, then it will be this 1 by 2 into 1 by 2 plus, now a win and a draw. Now which one is a win? So it will be this 2C1, and probability of winning is 1 by 2, and probability of making a draw, it is 1 by 6. Now this 2 and 2 will cancel. Now we'll get this as 12. So this probability will be 5 by 12, and that's your option B. Now we have the second case when the value of X is equal to value of Y. Now again for this we have 2 cases. Either it will be this win-lose, lose-win, or it will be both draws. Now in this case it will be 3-3 and here it will be 2-2. Now if we have to calculate this probability when the value of X is equal to Y, that will be a win and a loss. Now which one is a win? So it will be this 2C1, and probability of winning is 1 by 2 and probability of losing is 1 by 3 plus, now both draws, it is 1 by 6 into 1 by 6. Now this 2 and 2 will cancel. Now this is 36, 12 plus 1, 13. So this value will be 13 by 36, and that's your option C. Now here the question is, we are given that probability of X is 1 by 3, probability of x upon y, which is probability of x intersection y upon probability of y, it is 1 by 2, and probability of y by x, which is probability of x intersection y upon probability of x, it is 2 by 5. Now since we have probability of x, then from this first and third we can calculate probability of x intersection y, and this probability will be px into 2 by 5. So it will be this 2 by 15. Now once we have x intersection y and we put it in this second one, we get py. So this py, it will be 2 times px intersection y, and which is 4 by 15. That means this option D, it is correct. Now once we have all three values, we can calculate p x union y. Now this is px plus py minus px intersection y, which is 2 by 15. Now this is 1 by 3 plus 2 by 15, which is 7 by 15. That means this option C is incorrect. Now px intersection y, it is 2 by 15, not 1 by 5. So that means this p is also incorrect. Now we have to find p x naught upon y. Now p x naught upon y is p x naught intersection y upon probability of y. Now this is probability of y minus probability of x intersection y upon probability of y, and which is nothing but 1 minus probability of x by y, which is 1 minus 1 by 2, and that is 1 by 2. That means option A is also correct. So the correct options are A and D. Now here the question is, suppose there are 8 white and 2 red balls in a pocket. Each time one ball is drawn and replaced by a white ball. The probability of drawing out all the red balls just in the fourth draw is. So we have to find this probability that all the red balls are drawn in fourth draw. Now it should be just in fourth draw. That means this fourth draw, it must end in red. Now this first red, it can either be this first, second or third. So the possibilities are either it could be this R, W, WR, or WR, WR, or WW, R and R. So these are the three possibilities in which both the red balls, they are drawn in fourth draw. Now probability of getting a red ball in this first part will be simply 2 by 10. Now probability of getting a white ball. Now since first ball is red, it's being replaced with white. So now we have 9 white and 1 red. So it will be this 9 by 10 into 9 by 10 into 1 by 10. Now here first one is white, so it will be this 8 by 10. Now second one is red, so it will be this 2 by 10. Now we'll have 9 white and 1 red, so it will be this 9 by 10 into 1 by 10. Now this white is 8 by 10 into 8 by 10. Now here it is 2 by 10 and here it is 1 by 10. So this required probability will be this 9 into 9 into 2, that is 81 into 2 plus 72 into 2 plus 64 into 2 divided by 1000. Now this is 434 divided by 1000, which is nothing but 0.0434, and that's your option B. Now here the question is, 4 dice are thrown simultaneously. It is given that 4 and 2 has appeared on any 2 of them. We need to find the probability that 3 has appeared on the remaining dice. Now this is conditional probability problem. Now suppose this is this event D, that from this 4 dice we have 4 and 2, and then this is this event A, which is probability that 3 has appeared on the remaining die. Now we need to find this conditional probability. Probability of A by B. Now this is probability of A intersection B upon probability of B. Now first we'll calculate probability of B. And probability of B is actually the probability that when we have thrown 4 dice, then 4 and 2, they have appeared in any 2 of them. Now we can solve this using inclusion exclusion. Now total number of ways, which is 6 to the power 4 minus all those cases in which at least one of them is missing. So if 4 is missing, then it'll be this 5 to the power 4. And if 2 is missing, it'll be this 5 to the power 4 minus this case when both of them they are missing, because this case is included twice. So there'll be this minus 4 to the power 4. So this required probability will be 6 to the power 4 minus 2 into 5 to the power 4 plus 4 to the power 4 whole divided by total number of ways is 6 to the power 4. Now this is 302 upon 6 to the power 4. So the probability that both 4 and 2 they'll appear will be this 302 upon 6 to the power 4. Now we'll find this probability of A intersection B. Now this A intersection B, we have a 4, we have a 2, and then we have 2 3s. Now in this case, out of these 4 dice, we need to select 2 dice for these 3 and 3. So out of these 4, we can select any 2 in 4C 2 ways. Now the remaining 2 dice, we can distribute 4 and 2 in factorial 2 ways. So that will be 4C2 into factorial 2 divided by 6 to the power 4. Now 4C2 is 12 upon 6 to the power 4. So this conditional probability will be simply 12 upon 302, which is 6 upon 351, and that's your option D. Now here the question is, let omega be a complex cube root of unity with omega unequal to 1. A fair die is thrown 3 times. If R1, R2 and R3 are the numbers obtained on the die, then the probability that omega to the power R1 plus omega to the power R2 plus omega to the power R3 is 0. Now we know that 1 plus omega square, it is 0. So we'll get 1 when the value of R is either 3 or 6. We'll get omega if it is either 1 or 4, and we'll get omega square if it is either 2 or 5. So that means for R1, R2 and R3, we have to choose one number from this set, one number from this other set, and one number from this third set. So from this first one, we can choose one number in 2C1 ways. For second, it will be 2C1, and for third, it is 2C1. Now once we have 3 numbers, they can be distributed in R1, R2 and R3 in factorial 3 ways. So it will be this factorial 3 divided by now total number of ways, which is 6 into 6 into 6. Now this factorial 3 will cancel. This probability will be simply 2 by 9, and that's your option C. Now here the question is, 1 Indian and 4 American men and their wives are to be seated randomly around a circular table. Now total number of ways of distributing these 10 people on a circular table, it is given by factorial 9. Now we need to find this conditional probability that Indian man is seated adjacent to his wife, given that each American man is seated adjacent to his wife. Now say this event is I and this event is A. So we have to find this probability of I by A. Now first we'll calculate this probability that all American men, they are sitting adjacent to their wife. So here we have 4 pairs of American couples, and then we have Indian husband and Indian wife. Now we have to arrange these 6 objects on a circle, which can be done in factorial 5. Now each American couple, they can be arranged as factorial 2, factorial 2, factorial 2 and factorial 2 ways. So this property will be this factorial 5 into factorial 2 to the power 4 divided by factorial 9. So it will be this factorial 5 2 to the power 4 upon factorial 9. Now we'll find this property that I intersection A. Now in I intersection A, along with 4 American, this Indian couple, they are also together. So now we have 5 objects which can be arranged in factorial 4 ways, and then these 5 couples, they can be arranged in factorial 2 to the power 5 ways divided by factorial 9. Now we need to find this conditional probability that Indian couple is together given that American men, they are with their wives. So this probability will be this factorial 4 into 2 to the power 5 upon factorial 5 and 2 to the power 4. Now this probability simply will be 2 by 5, and that's your option C. Now here the question is, a ship is fitted with 3 engines, E1, E2 and E3. The engines function independently of each other with probabilities 1 by 2, 1 by 4 and 1 by 4. Now for ship to be operational, at least 2 of the engines must function. Let X denote the event that ship is operational, and X1, X2 and X3 denote respectively the events that engines E1, E2 and E3 are functioning. Then which of the following is or are true? Now we are given that probability of X1 is 1 by 2, probability of X2 is 1 by 4 and probability of X3 is also 1 by 4. Now X is the event that ship is operational. Now ship is going to be operational if at least 2 of the engines are functioning. So it could be either X1, X2 but not X3, or X1, X3 but not X2, or X2, X3 but not X1, or all 3 of them, they are functioning, X1, X2 and X3. Now first we will calculate the probability that this ship is operational. Now this probability will be 1 by 2 into 1 by 4 into 3 by 4 plus 1 by 2 into 1 by 4 into 3 by 4 plus 1 by 4 into 1 by 4 into 1 by 2 and plus 1 by 2 into 1 by 4 into 1 by 4. Now this probability will be 6 into 8 divided by 32, which is 1 by 4. Now for the first one, we have to find this conditional probability that X1 is not operational given that ship is operational. Now this is probability of X1C intersection X divided by probability of X. Now if ship 1 is not operational, it is only this third case. Now in this case, this probability is 1 by 32 divided by probability of X, which is 1 by 4. Now this probability will be simply 1 by 8. So that means this option A, it is incorrect. Now this option B is probability exactly 2 engines of the ship are functioning provided it is running. So probability of say E by X. Now will be probability of A intersection X upon probability of X. Now if 2 of them they are running, so it will be this probability for these 3 cases, which is 7 by 32 upon 8 by 32. So this probability will be simply 7 by 8. That means this option B is correct. Now C is probability that X if X2. So this is probability of X intersection X2 upon probability of x2, if x2 is running and chip is operational, will be this first case, third case and fourth case, which is 5 by 32 divided by probability of x2, and probability of x2 is 1 by 4. So it will be simply 5 by 8. So that means this option C, it is incorrect. And if we look at this fourth case, which is probability of x by x1, so it will be this probability of x intersection x1 upon probability of x1. Now if x1 is running, it will be this first case, second case and third case. So it will be this 6 plus 1 7, so it will be 7 by 32 upon probability of x1, which is 1 by 2. So this probability will be 7 by 16. That means this option D is also correct. So the correct options are B and D. Now here the question is, 4 fair dice D1, D2, D3 and D4, each having 6 faces numbered 1 to 6 are rolled simultaneously. The probability that D4 shows a number appearing on one of D1, D2 and D3. Now here we have to consider 3 cases. Case 1, when D1, D2 and D3, they have same number, say x, x and x. Now D4 must show a number appearing on one of D1, D2 and D3. Now in this case, D4 must also have x. So that means all the 4 dice, they'll show the same number. Now this probability will be given by 6 upon and then 6 into 6 into 6 into 6. So there will be 1 upon 216. Now we have the second case when 2 of the die, they'll show the same number, say x, and third die, it shows y. Now 2 same numbers, it can be any one out of 6c1, and then 1 distinct will be this 5c1. And once we have x, x and y, it can be arranged among d1, d2, d3 in 3 ways. So now we have x, x and y. Now in this case, this D4, it can either be x or it can either be y. So we have 2 favorable cases for D. So this will be 6 into 6 into 6 into 6. Now this 6 will cancel. This 6 will also cancel. So this probability will be 5 by 36. Or we can also write this as 30 by 216. Now we'll have this third case when all the 3 numbers, they are distinct. So it will be this x, y, z. So we have to choose 3 numbers which can be done in 3 ways. Now these 3 numbers, they can be distributed among 3 dice in factorial 3 ways. And this D4, it can take any one of these 3. So it will be this 3c1 divided by 6 into 6 into 6 into 6. So this factorial 3 will cancel. Now this is 20 into 3, 60. So it will be this 60 upon 216. So this probability that D4 shows the same number as one of the 3 dice will be sum of all these 3 cases, which is simply 91 upon 216. And that's your option A. Now here the question is, let E and F be 2 independent events. The probability of exactly one of them occurs is 11 by 25 and probability of none of them occurring is 2 by 25. If PT denotes the probability of occurrence of the event T, then we have to find the value of PE and PF. Now suppose PE is E and PF is F. Now probability exactly one of them occurs is probability of E intersection F naught plus probability of E naught intersection F, and this probability is 11 by 25. Now since they are independent, so it will be this E into 1 minus F plus F into 1 minus E, and it will be 11 by 25. So we can write this as E plus F minus 2 E into F will be 11 by 25. And the next one is none of them occurring. So none of them occurring is probability of E naught intersection F naught, and will be this 2 by 25. Now this is 1 minus E into 1 minus F, and it is 2 by 25. So we can write this as 1 minus E minus F plus EF will be 2 by 25, or E plus F minus EF will be 23 by 25. Now if we subtract this first from second, we can write E into F as 12 by 25 and E plus F as 35 by 25. Now this is 7 by 5. Now their product is 12 by 25 and their sum is 7 by 5. Now this is 2 into 6, 4 into 3. So we can write this as 4 by 5 into 3 by 5, and here will be this 4 by 5 plus 3 by 5. So one of them is 4 by 5 and the other one is 3 by 5. That means this option A or this option D. So the correct options are A and D. Now here the question is, 3 6-faced square die are thrown together. Let pk denote the probability that sum of numbers appearing on dice is k, and if this summation k varies from 9 to 14 pk, then find the value of 54s minus 30. Now suppose number on first die is x1, number on second die is x2, and number on third die is x3, and it must be equal to k, where each of xi can take the value from 1 to 6. Now since for each x we have a minimum and a maximum, so what we'll do is we'll solve this question using binomial theorem. So that means we have to find coefficient of x to the power k in the expansion of x plus x square up to x6, and since we have 3 dice, so it will be this power 3. Now we can take x cube common, so basically we can write, we have to find coefficient of x to the power k minus 3 in the expansion of 1 plus x square up to x to the power 5 to the power 3, or we can write coefficient of x to the power k minus 3 in the expansion of 1 minus x to the power 6 upon 1 minus x whole cube, which is coefficient of x to the power k minus 3 in 1 minus x to the power 6 to the power 3 into 1 minus x to the power minus 3. Now value of k, it lies from 9 to 14. Now k minus 3 is 6 up to 11. So this power, it goes from 6 to 11. So we can write this as, we need to find coefficient of x to the power k minus 3 in 1 minus 3x to the power 6, and we'll discard higher powers into 1 minus x to the power minus 3. Now we know that coefficient of x to the power r in the expansion of 1 minus x to the power minus 3 will be n plus r minus 1 CR. So there will be 3 plus r minus 1 CR, or we can write this as r plus 2 C2. So it will be this coefficient of x to the power k minus 3 in 1 minus 3 into x to the power 6, and then this binomial summation of r plus 2 C2 x to the power r. Now we get coefficient of x to the power k minus 3 if we take r as k minus 3. So it will be this k minus 3 plus 2 C2 and then minus 3 into now x to the power 6 into x minus r. So it will be coefficient of k minus 9. So there will be k minus 9 plus 2 c2. So sum of the numbers will be k in k minus 1 c2 minus 3 into k minus 7 c2 ways. Now we need to find this probability that this sum is k. So this probability will be given by k minus 1 c2 minus 3 into k minus 7 c2 divided by total choices, and that will be 6 into 6 into 6, and that is 216. Now we need to find this S, which is this summation k varies from 9 to 14 pk, and which will be this summation k minus 1 c2 where k varies from 9 to 14 minus 3 times this summation k varies from 9 to 14 k minus 7 c2 divided by 216. Now we need to solve these two summations. Now if we look at this summation, which is summation k minus 1 c2 where k varies from 9 to 14, basically it will be this 8c2 plus 9c2 up to 13c2. Now what we'll do is we'll add 8c3 and we'll subtract 8c3. Now n same r differs by 1, so it'll be this 9c3, again 9c2 plus 9c3, it'll be 10c3, and finally it'll be 13c2 plus 13c3, and that'll be 14c3. So this value will be 14c3 minus 8c3. And if we look at the second series, which is this summation k varies from 9 to 14 k minus 7c2. Now this is 2c2 plus 3c2 up to 7c2. Now 2c2 is 1. We can also write this as 3c3. So next one will be 4c3, and finally it will be 8c3. So this first summation is 14c3 minus 8c3, and this second summation is 8c3. Now we put the values of these summation, then we can write this S as 14c3 minus 8c3 and minus 3 8c3. So that will be 4 into 8c3 divided by 216. Now 14c3 is 14 into 13 into 12, and this is 6 minus 4. Now this is 8, 7, 6, and this is 6 divided by 216. Now this is 2 and this is 6. So it will be this 28 into 13 minus 8. 13 minus 8 is 5 divided by 216. Now this is 7, 54. So it will be this 35 by 54. So value of S is 35 by 54. Now we need to find the value of 54S minus 30. Now 54S minus 30, and there will be 35 minus 30, which is simply 5. So answer to this question is 5. Now again the question is, a coin is tossed n plus n times where m is greater than n. Then we need to show that probability of at least m consecutive heads is. Now this coin, it is tossed m plus n times. M consecutive heads, they may start from this first place, or they may start from the second place, or this third place. So they may start from any place from 1 to n plus 1. Now if m consecutive heads, they start from this first place from this place. Now it should be heads here. So we'll have heads in m consecutive positions. So for each head, we have 1 by 2 possibility. So it will be 1 by 2, 1 by 2, 1 by 2, m times. So if these consecutive heads, they start from first place, this probability is 1 by 2 to the power m. Now, if these heads, they start at second place. Now clearly this first one, it has to be tails now. So this probability is 1 by 2, and again these m consecutive heads will be 1 upon 2 to the power m. So it will be this 1 upon 2 to the power of m plus 1. Now if we look at this third place, now before third, it should be this tails. So again it will be 1 upon 2 to the power of m plus 1. So for any I between 2 and m plus 1, the probability that m consecutive heads start at ith place will be 1 upon 2 to the power of m plus 1. So this required probability will be 1 upon 2 to the power m plus 1 upon 2 to the power of m plus 1, 1 upon 2 to the power of m plus 1, n times. So it will be this n into 1 upon 2 to the power of m plus 1, which is simply n plus 2 upon 2 to the power of m plus 1, which is what we need to prove in this question. Now here the question is, let Pn be the probability that n throws of a fair die contains an odd number of 6s. Now probability of getting a 6, it is 1 by 6, and probability of not getting a 6 is 5 by 6. Now if we throw n dice, then we can write this as q plus p to the power n, and it will be nc0 q to the power n plus nc1 q to the power n minus 1 p, nc2 q to the power n minus 2 into p square, and if we take q minus p, it will be q minus p to the power n, nc0 q to the power n minus nc1 q to the power n minus 1 p, and so on and so forth. Now it says Pn is the probability that it contains odd number of 6s. So odd number will be 1, 3. That means we need to find some of these even number terms, second term, fourth term. So what we'll do is we'll subtract these two. If we subtract, we can write q plus p to the power n minus q minus p to the power n, and it will be equal to 2 times nc1 q to the power n minus 1 p, nc3 q to the power n minus 3 p3. Now p plus q is 1 and q minus p is 4 by 6, which is 2 by 3. So it will be this 2 by 3 to the power n, and this is equal to 2 times pn. So basically in this, pn is 1 by 2 into 1 minus 2 by 3 to the power n. Now if we look at pn minus 1, pn minus 1 will be 1 by 2, 1 minus 2 by 3 to the power n minus 1. Now from the first one we can write 2 by 3 to the power n will be 1 minus 2pn, and from second we can write 2 by 3 to the power n minus 1 will be 1 minus 2 p n minus 1. Now we multiply 2 by 3 in the second, we can write 2 by 3 to the power n, and it will be 2 by 3 1 minus 2 p n minus 1, which is equal to 1 minus 2 pn. So it will be 1 minus 2 pn. Now if we cross multiply, we can write 2 minus 4 pn minus 1 will be equal to 3 minus 6 pn, or we can write 6 pn minus 4 pn minus 1, minus 1 equals 0. And that's your option A. Next, the question is, box 1 contains 3 cards bearing numbers 1, 2 and 3. Box 2 contains 5 cards bearing number from 1 to 5. And box 3 contains 7 cards bearing number from 1 to 7. A card is drawn from each of the boxes. Let xi be the number on the card drawn from the ith box. Now the first one is the probability that x1 plus x2 plus x3 is odd. Now we have 3 boxes, 1, 2 and 3. And the first one we have 3 numbers, 1, 2, 3. Here we have 1, 2, 3, 4 and 5. And here we have 1, 2, 3, 4, 5, 6 and 7. Now from this one we have selected x1. Here we have selected x2. And here we have selected x3. Now first one is we need to find the probability that x1 plus x2 plus x3 is odd. Now it will be odd if all 3 of them they are odd, or we get odd from one and then even from other 2, or it could be odd from second, or it could be odd from third. So these are the 4 possible cases. Now getting an odd from this first box, it is 2 by 3. Odd from second is 3 by 5. And odd from third is 4 by 7. Now plus odd from first 2 by 3. Even from second 2 by 5. Even from third 3 by 7. Now even from first 1 by 3. Odd from second 3 by 5. And then it will be this 3 by 7 plus, now even is 1 by 3. It is 2 by 5. And then here it will be this 4 by 7. And that's the required probability. Now this probability will be 24 plus 12 plus 9 plus 8 divided by 105. Now this is 20, 44. 44 plus 9 is 53. So this probability will be 53 upon 105, and that's your option B. Now the second part is we need to find the probability that x1, x2, x3 are in AP. Now it can be an AP with common difference of 0. In that case we'll have 1, 1, 1, 2, 2, 2 and 3, 3, 3. If we say common difference of 1, then we can have 1, 2, 3, 2, 3, 4, 3, 4, 5. If we take common difference of 2, then we'll have 1, 3, 5, 2, 4, 6, 3, 5, 7. And if we consider common difference of 3, then we'll have 1, 4 and 7. Now t equals to 4 is not possible. Now there is one more case when the value of d is -1, and there we can have 3, 2 and 1. So these are the possible cases for an AP. Now it will be this 3, 3 and 3, 9, 9 plus 2, 11. So total number of ways in which we can choose x1, x2, x3, they are in AP. It is 11. So this required probability, it will be 11 upon. Now total number of ways of choosing them. Now for the first one it is 3. For the second one it is 5. And then it is 7. So it will be this 11 upon 105. And that's your option C. Now the next one is the minimum number of times a fair coin needs to be tossed so that probability of getting at least 2 heads is at least 0.96. Now getting a heads, it is success. This probability is 1 by 2 and getting a tails is 1 by 2. And suppose n is number of times we are tossing this coin. Now we need to find this probability that x is greater than or equal to 2. Now we can write this as 1 minus probability of x less than 2. So it will be this 1 minus probability x equals 0 minus probability x equals 1. Now it says this probability is at least 0.96. So we can write 1 minus, now probability of x equal to 0 is nc0 1 by 2 to the power n minus nc1 1 upon 2 to the power n, and it should be greater than or equal to 0.96. Now we can write this as n plus 1 upon 2 to the power n. It should be less than or equal to 0.04. Now we can write this as 100 into n plus 1 should be less than or equal to 2 to the power of n plus 2. Now this is greater than 100, so that means 2 to the power n plus 2, it should be greater than 100. So basically value of n, it should be greater than or equal to 5. Now we take n as 5. Now it will be this 600, and here will be this 2 to the power 7, which is 128, not possible. So we take 6. Now since it is greater than 500 here, so here this value, it should be at least 8. So if we try n as 8, then we'll get 8 plus 1, 900, and which is less than 2 to the power 10, which is 1024. So minimum value of n is simply 8. So the minimum number of times this fair coin must be tossed is 8, and that is the answer to this question. Now the question is, let n1 and n2 be number of red and black balls respectively in box 1, and let n3 and n4 be number of red and black balls in box 2. So we have two boxes, box 1 and box 2. Now in box 1 we have n1 red and n2 black balls, and here we have n3 red and n4 black balls. Now one of the two boxes was selected random and a ball was drawn randomly out of this. The ball was found to be red. The probability that this red ball was drawn from box 2 is 1 by 3. Then which of the possible values of n1, n2, n3, n4 is or are? Now basically it's a problem of base theorem. So if ball is found to be red, then the probability that it has come from this second box will be given by, now probability of choosing this second box, it is 1 by 2, and then probability of choosing a red ball from this second box is n3 upon n3 plus n4 divided by total number of ways. Now total number is, if it is first box, we can choose it in 1 by 2 ways, and then getting a red ball is n1 upon n1 plus n2 plus 1 by 2 into n3 upon n3 plus n4, and this probability is 1 by 3. Now 1 by 2 will cancel. Now we can simplify this as n3 into n1 plus n2 upon n1 into n3 plus n4 plus n3 into n1 plus n2, and this is equal to 1 by 3. Now we can write this as 3 n1 n3 plus 3 n2 n3, and it will be equal to n1 n3 plus n1 n4 plus n1 n3 plus n2 n3. Now n1 n3 twice will cancel here. Now this n2 n3 will be this 2, so we can write 2 times n2 n3, it must be equal to n1 into n4 minus n3. Now we have to check all the options. Now 2 into n2 n3. So here will be this 15. 15 into 2 is 30. And n1 is 3. And n4 minus n3 will be this 10. So it will be this 30. That means this option 8 is correct. Option B is 6 and 10, 60. 60 into 2, 120. N1 is 3. And N4 minus N3 is 40. So it will be this 120. Option B is also correct. Now this is 2 into 6 into 5. So it will be this 60. And here it is 8 into 15. 15 into 8 is 120. So that means option C is incorrect. And here it is 12 into 5 into 2, 120. And it will be equal to N1, which is 6 into 15. 15 into 6 is 90. So this is also incorrect. So the only correct options are A and B. Then the second part, it says a ball is drawn at random from box 1 and it is transferred to box 2. If the probability of drawing a red ball from box 1 after this transfer is 1 by 3, then the correct options with possible values of N1 and N2 are. Now from the box 1, we have transferred one ball. Now this ball, it could be red or it could be black. Now it is red with the probability N1 upon N1 plus N2. It is black with the probability N2 upon N1 plus N2. Now after this transfer, we have drawn a ball from this first one. Now this first one has N minus 1 red and N2 black. So probability of drawing a red ball is N1 minus 1 upon N1 plus N2 minus 1. And in this case, it will be N1 upon N1 plus N2 minus 1. So probability of drawing a red ball after this transfer will be N1 into N1 minus 1 plus N1 into N2 upon N1 plus N2 into N1 plus N2 minus 1, and this probability is equal to 1 by 3. Now here if we take N1 common, we can write this as N1 plus N2 minus 1 upon N1 plus N2 upon N1 plus N2 minus 1, and this is 1 by 3. Now here it will cancel. So this probability will be N1 upon N1 plus N2 will be equal to 1 by 3, or 2N1 must be equal to N2. Now option A, it is not true. Option B is also not true. Correct options are C and D. And that is the answer to this question. Now here the question is, let H1, H2 and Hn be mutually exclusive and exhaustive events such that probability of Hi is greater than 0. And let E be any other event with probability of E lying between 0 and 1. Now statement 1 is probability of Hi upon E is greater than probability of E upon Hi into PH1 because summation PHI equals 1. Now since these events are mutually exclusive and exhaustive, then clearly summation PHI will be 1 where I varies from 1 to n. So that means the statement 2, it is correct. Now if we look at probability of Hi upon E, we can write this as probability of Hi intersection E upon probability of E. Now what we can do is we can multiply and divide it with PHI. We are going to write this as PHI intersection E upon PHI into PHI upon PE. Now this is nothing but this is PE upon HI. So there will be PE upon HI into PHI divided by PE. Now since PE lies between 0 and 1, so it will be greater than P E upon HI into PHI. So the statement 1, it appears correct, but then there is this one case if PHI intersection E is 0, then in that case left hand side and right hand side, they both become equal to 0. In that case the statement 1 is not correct. So the statement 1 is not always correct. So in some books you'll find this answer as both the statements are correct and statement 2 doesn't explain statement 1. And in some books you'll find it, they'll say statement 1 is wrong and statement 2 is correct. However, one of the iconic teachers, Professor K.D. Joshi from IIT Bombay, he maintains that both the statements are correct and statement 2 doesn't explain statement 1. Now here the question is, consider the system of equations ax plus by equals 0 and cx plus dy equals 0, where a, b, c, d, they take the value either 0 or 1. So what are the total number of ways in which we can define a, b, c, d? So for each we have two options. So total number of ways to define these equations will be 2 into 2 into 2 4 times, and that will be 16. Now statement 1 is probability that system of equation has a unique solution is 3 by 8, and statement 2 is the probability that system of equation has a solution is 1. Now since this is a homogeneous equation, it will always have a trivial solution. So x equal to 0 and y equal to 0 will always be one of the solutions. So the system of equation will always have a solution, and therefore it is a sure event. That means the statement 2 is correct. Now for the statement 1, we have to check the condition that the system of equation has unique solution. Now homogeneous equations will have unique solution if the determinant a, b, c, d, it is unequal to 0. That means AD minus BC, it is unequal to 0. Now it will be unequal to 0 when one of them is 1 and another one is 0. So we have this first case when AD is 1 and BC is 0, and this second case when AD is 0 and BC is 1. Now if AD is 1, then A should be 1 and D should be 1. Now if B into C is 0, we can have B0 C1, C0 B1, or B equals to 0 and C equals 0. Now here we have B into C as 1, so B should be 1 and C should be 1, and here we'll have either A0 D1, D0 A1, or both of them 0. So altogether we have 6 cases when the value of this determinant is non-zero. So this required probability will be 6 by 16, which is 3 by 8. That means the statement 1 is correct. So statement 1 is correct and statement 2 is correct, and we have not used any part of statement 2 to prove statement 1. So that means statement 2 does not explain statement 1. Now here we are given two events as that P A union B naught is 1 by 6. That means probability of A union B will be 5 by 6. Probability of A intersection B is 1 by 4, and probability of A is 3 by 4. We can find probability of B and will be 5 by 6 plus 1 by 4 minus 3 by 4, and that will be 1 by 2, 1 by 3. Now since probability of A and probability of B, they are different, so these events are not equally likely. And if we look at PA into PB, this value will be simply 1 by 4, which is same as PA intersection B. That means these two events are independent but not equally likely. That means this option C is correct. Now here the question is, 3 6-faced fair dice are thrown together. The probability that sum of numbers appearing on dice is K. That means we have to find coefficient of x to the power k in the expansion of x plus x square up to x to the power 6, and together they are 3 fair dice. So it will be this 3. Now we can take x cube common, so we can find coefficient of x to the power k minus 3 in the expansion of 1 minus x to the power 6 to the power 3 into 1 minus x to the power minus 3. Now since k minus 3 it is less than 6, so that means we simply have to find coefficient of x to the power k minus 3 in the expansion of 1 minus x to the power minus 3. Now coefficient of x to the power r in the expansion of 1 minus x to the power minus n, it is given by n plus r minus 1 cr. So it will be this k minus 1 c2, which is k minus 1 into k minus 2 whole divided by 2, and that's your favorable cases. Now total number of cases will be 6 into 6 into 6. So this required probability will be k minus 1 into k minus 2 divided by 2 into 216, which is k minus 1, k minus 2 and 432. That's your option A. Now here the question is, for 3 events A, B and C, P exactly one of the event A or B occurs is equal to P exactly one of events B or C occurs equals P exactly one of events C or A occurs is P, and probably all the 3 events occur simultaneously is P square. Then the probability that at least one of the 3 events occurs is. Now we are given that exactly one of A or B. Now we know that probability exactly one of A or B, it is probability of A intersection B naught plus probability of A naught intersection B, and is given that this is P. Now we can write this as PA minus PA intersection B, and this is PB minus PA intersection B, and this is P. So from here we can write PA plus PB minus 2 times P A intersection B, it is P. In the same way we can write PB plus PC minus 2 times P B intersection C, it is also P, and also PC plus PA minus 2 times P A intersection C, it is P. Now if we add all these 3, we can write 2 times PA plus PB plus PC minus P A intersection B minus P B intersection C minus P C intersection A, it is 3P. Now we have to find at least one of A, B, C must occur. Probability of A union B union C. Now this probability is PA plus PB plus PC minus P A intersection B minus B intersection C minus C intersection A plus probability of A intersection B intersection C. Now we already know this value. This is 3P by 2. So we can write this as 3P by 2, and intersection, all these 3 occur simultaneously. It is given in the question as P square. So this probability will be 2P square plus 3P by 2, which is your option A. Now the question is, 2 events A and B are such that PA dash is 0.3. That means PA is 0.7, probability of B is 0.5, and probability of A intersection B is 0.3. Now we need to find this probability B upon A union B naught. Now this is probability of A union B naught intersection B upon probability of A union B naught. Now this is A and B naught, and if you are taking its intersection with B, so it will be simply probability of A intersection B, and we know that probability of A union B naught will be probability of A naught intersection B naught, or we can write this as probability of A intersection B upon 1 minus probability of A naught intersection B. Now this is probability of A intersection B, and we can write this as 1 minus probability of B minus minus plus probability of A intersection B. Now this probability is 0.3. This is 1 minus 0.5 plus 0.3, which is 3 by 8, and that's your option A. Now here the question is, assume that for every person the probability that he has exactly one child, two children and exactly three children are 1 by 4, 1 by 2 and 1 by 4. The probability that a person will have 4 grandchildren can be expressed as P upon Q. Then find the value of 5P minus Q. Now this person, he can have either one child or two children or three children. Now if it is one child, probability is 1 by 4. For two children it is 1 by 2, and for three children it is 1 by 4. Now he's supposed to have 4 grandchildren. Now with one child he cannot have 4 grandchildren. So we'll consider these two cases. So if he has 2 children, then each of these 2 children can have 1, 2 and 3 children. And in the same way, for 3 children also, he'll be this 1, 2 and 3. Now he'll have 4 grandchildren if he has 2 children and then followed by either 1, 3 or 3, 1 or 2, 2, or he has 3 children and then he can have 1, 1, 2. So it could be 1, 1, 2 or 1, 2, 1 or 2, 1, 1. Now this required probability will be, now probability of having 2 children, it is 1 by 2 into now 1 and 3. 1 and 3 is 1 by 4 into 1 by 4. So it will be 1 by 16. 3, 1 is also 1 by 16. And then 2, 2 is 1 by 4. Plus probability of 3 children, it is 1 by 4. And then 1, 1, 2. 1, 1, 2 is 1 by 4, 1 by 4 and 1 by 2. And that will be 1 by 32. And there will be 3 cases. So it will be 6 by 32 plus 3 by 128. Now we simplify this, it will be this 128, it will be this 27 upon 128, and that's the value of P by Q. Now we need to find the value of 5P minus Q. So it will be 5 into 27 minus 128, and that will be simply 7. So answer to this question is 7. Now here the question is, A and B are 2 independent events such that probability of A is 1 by 2, probability of B is 1 by 5, and since they are independent, probability of A intersection B will be PA into PB, which is 1 by 10. Now using this, we can calculate probability of A union B, which is probability of A plus probability of B minus probability of A intersection B. So that will be 6 by 10, and 6 by 10 is 3 by 5. That means option A is correct. Now since A and B, they are independent, probability of A by B will be simply equal to probability of A, which is 1 by 2. That means option B is also correct. Now if we look at probability of A upon A union B, then it will be this probability of A intersection A union B upon probability of A union B. Now A intersection A union B is probability of A. So it will be this probability of A upon probability of A union B. Now probability of A is 1 by 2 and A union B is 3 by 5. So this probability is actually 5 by 6, and that's your option C. Now if we look at this option D, then in option D we have this probability of A intersection B upon A naught union B naught. Now this is probability of A intersection B intersection A naught union B naught upon probability of A naught union B naught. Now if we look at this Venn diagram, A intersection B is this region, and A naught union B naught is, now A naught is everything which is not A, and B naught is everything which is not B. That means it contains all the region except this A intersection B. So there is nothing common in between the two regions. So this probability, it has to be 0. That means this option D is also correct. So the correct options are A, B, C, D. Now the question is, probability of A is 1 by 2 and probability of B is 2 by 3. Now we know that P A union B, it is always greater than or equal to maximum of PA and PB. Now maximum of P and PB is PB. That means probability of A union B, it must be greater than or equal to 2 by 3, and we know that any probability is always less than or equal to 1. That means this option A, it is correct. Now if we look at A intersection B, we can write probability of A intersection B as probability of A plus probability of B minus probability of A union B, which is 7 by 6 minus probability of A union B. Now this value will be maximum when A union B is minimum, which is 2 by 3. So 7 by 6 minus 2 by 3, and there will be 7 minus 4, which is 1 by 2. So its maximum value will be 1 by 2, and it will be minimum when we put maximum value of P A union B, which is 1, which is 1 by 6. So this value will lie between 1 by 6 and 1 by 2. So that means option C is also correct. Now we look at this option B. This is probability of A intersection B naught, and it is probability of A minus probability of A intersection B. Now probability of A is 1 by 2 minus probability of A intersection B. Now it will have its maximum value when A intersection B is minimum. Its minimum value is 1 by 6. So if we put 1 by 2 minus 1 by 6, it will be 3 minus 1 by 6. So it will be simply 1 by 3. That means this option B is also correct. Now the same way we can write probability of A naught intersection B. Now probability of A naught intersection B, it is probability of B minus probability of A intersection B. Now probability of B is 2 by 3 minus A intersection B has two values, 1 by 6 and 1 by 2. Now we take 1 by 6, then it will be 1 by 2, which is its maximum value, and if we put 1 by 2, then it will be this 1 by 6. So that means all the four options A, B, C, D, they are correct. Now for two events, it is given that probability of A is 1 by 4, probability of A upon B, which is probability of A intersection B upon probability of B, it is also 1 by 4, and probability of B by A, which is probability of A intersection B upon probability of A, it is 1 by 2. Now we put the value of probability of A as 1 by 4, we'll get probability of A intersection B as 1 by 8. Now from A intersection B, we can find the value of probability of B. So now probability of B will be 4 times A intersection B, which is 1 by 2. Now PA into PB, it is 1 by 4 into 1 by 2, which is 1 by 8, and is same as P A intersection B. That means A and B are independent. And since the intersection is not 0, they are not mutually exclusive. Now if A and B are independent, then probability of A naught upon B will be same as probability of A naught, and probability of A naught is 3 by 4. That's your option C. And the same way, probability of B naught upon A naught will be same as probability of B naught, and which is 1 by 2. So the correct options are A, C and D. Now here the question is, in a test, an examinee either guesses or copies or knows the answer to multiple choice question with 4 choices. The probability that he makes a guess is 1 by 3. So making a guess, it is 1 by 3. He copies the answer, it is 1 by 6. Now knowing is 1 minus sum of these two, as these 3 are mutually exclusive and exhaustive. So it will be 1 minus 1 by 3 plus 1 by 6. And that should be 1 by 2. Now probability his answer is correct given that he guesses it. Now there are 4 options, out of which 1 is correct. So this probability when A by G, it is 1 by 4. Probability answer is correct given that he copies it, it is given as 1 by 8. And probability that his answer is correct when he knows the answer, it has to be 1. Now we need to find the probability that he knew the answer given that he answered it correctly. So that means it's a Bayes theorem question, and we need to find he knows the answer given that his answer is correct. So we'll take this case in the numerator. So it will be this 1 by 2 upon, now this is 1 by 3 into 1 by 4, 1 by 12, 1 by 6 into 1 by 8, 48, and plus 1 by 2. Now this is 1 by 2. This is 4 plus 1 plus 24 by 48. So it will be this 24 by 29, and that is the answer to this question. Now here the question is, a box contains 12 identical balls, of which 12 are white and 12 are black. The balls are drawn at random from the box, one at a time with replacement. The probability that a white ball is drawn for the 4th time on the 7th draw is. Now we have 6 draws, and this 7th draw, it must be a white ball. Now in the first 6, it has to be 3 white and 3 black. Now which 3 white? It will be this 6C3. Then probability of drawing a white ball, it is 1 by 2, and probability of drawing a black ball is also 1 by 2. So it will be this 1 by 2 to the power 6, and then probability of getting this 7th ball is white, it will be this 1 by 2. Now this is 20 upon 2 to the power 7, which is 5 by 32, and that's your option C. Now here the question is, there are 3 bags B1, B2 and B3, and bag B1 contains 5 red and 5 green balls. Bag B2 contains 3 red and 5 green, and bag 3 contains 5 red and 3 green balls. Now bags B1, B2 and B3 have probabilities of 3 by 10, 3 by 10 and 4 by 10 respectively of being chosen. A bag is selected at random and ball is chosen at random from the bag. Then which of the following options is or are correct? Now the first one is the probability that chosen ball is green. Now it will be green if it comes from first bag. The probability of choosing bag 1 is 3 by 10. Now from this bag 1, probability of choosing a green ball, it is 1 by 2 plus, now bag 2 is 3 by 10. Now probability of choosing a green ball, it is 5 by 8 plus third bag, which is 4 by 10, and then here green is 3 by 8. Now this is 12 and 12, 24. 24 plus 15 is 39. So this probability will be simply 39 divided by 80, and that's your option A. Now B is probability that chosen ball is green given that selected bag is B3. Now if we choose this bag number 3, then probability of choosing a green ball will be simply a green ball from these 8 balls. So it will be this 3C1 upon 8C1, which is 3 by 8, and that's your option B. Now probability that selected bag is B3 and the chosen ball is green. So this probability that selected bag is B3 and chosen ball is green will be given by this probability of choosing third bag, which is 4 by 10, and then probability of choosing a green ball, which is 3 by 8. So it will be nothing but 3 by 20. That means this option C, it is incorrect. The probability that selected bag is B3 given that the chosen ball is green. Now this fourth one, it is Bayes theorem question. So for this fourth one, we have to take this case in the numerator. So it will be this case in the numerator, which is 3 by 20 upon this total case, which is 39 by 80. Now this is 4, so it will be simply 12 by 39, which is 4 by 13. That means this option D is also incorrect. So the correct options are A and B. Now here the question is, the probability that a missile hits a target successfully is 0.75. Now in order to destroy the target completely, at least 3 successful hits are required. Then the minimum number of missiles that have to be fired so that probability of completely destroying the target is not less than 0.95. Now probability of success in this case is 0.75, which is 3 by 4, and probability of failure will be simply 1 by 4. And suppose number of hits is n, then this probability that target is destroyed will be given by P x is greater than or equal to 3. This probability is not less than 0.95. That means it should be greater than or equal to 0.95. Now we can write probability of x greater than or equal to 3 as 1 minus probability of x less than or equal to 2, and it should be greater than or equal to 0.95, or we can write probability of x less than or equal to 2, it should be less than or equal to 0.05. Now this is probability of x equal to 0, so it will be this nc0 p to the power 0 q to the power n plus nc1 p to the power 1 q to the power of n minus 1 plus nc2 p to the power 2 q to the power n minus 2, and will be less than or equal to 0.05. Now this is 1 by 4 to the power n. Now this is 3n upon 4 to the power n, and this is n minus 1 into 9 upon 2 into 4 to the power n, and will be less than or equal to 0.05. Now if we take LCM, we can write 2 plus 6n plus 9n square minus 9n. It should be less than or equal to 4 to the power n divided by 10. Or we can write this as 9n square minus 3n plus 2. It should be less than or equal to 4 to the power n divided by 10. Now we can rearrange this as 5 into 9 to the power n minus 3n plus 2 will be less than or equal to 2 to the power of 2n minus 1. Now we just have to put the value of n to check. So what we'll do is, we'll check it around 3 and we'll see if we need to increase the value of n or decrease the value of n. Now if we take n as 3, we'll get this as 2 to the power 5, 32, and here it will be 81. 81 into 5 will be, so what we'll do is we'll check n as 5. Now if we put n as 5, here we'll get 2 to the power 9, and 2 to the power 9 is 512, and here will be this 25 into 9, 225, minus 15 plus 2. Now this value is again greater than 512. Now if we look at n equals 6, for n equals 6, this value will be 2 to the power 11, and 2 to the power 11 is 2048, and here this value will be 5. 9 into 36 minus 18 plus 2, and here left hand side is 1540. So that means the smallest value of n for which this left hand side it is less than right hand side, it is 6. So answer to this question is simply 6. Now here the question is, from 2n plus 1 consecutive positive integers, 3 are selected at random. The probability that they are in AP is 3n upon 4n square minus 1, and from 2n consecutive positive integers, 3 are selected at random. The probability that numbers of them are in AP is 3 upon 2 into 2n minus 1. Now in one of the previous videos in permutations and combinations, we have already studied that if we have to choose 3 numbers in AP from n consecutive integers, then it will be 1 by 4 n minus 1 whole square if n is odd, and it will be 1 by 4 into n minus 2 if n is even. Now for the first one, if we have to select 3 numbers in AP, now in this case 2n plus 1, it is an odd number. So this required probability for this first case, it will be 1 by 4. Now n in this case is 2n plus 1, so it will be 2n plus 1 minus 1 whole square divided by total number of ways of selecting 3 from 2n plus 1, so it will be 2n plus 1 C3. Now this 3 and 3 will cancel, so we'll get this as n square upon, now this is 2n plus 1, 2n minus 1, and here it is this 6. Now n and n will cancel, now this is 3, so this value will be 3n upon 4n square minus 1, which is our first result. Now for the second one, we have even number of numbers. Now in this case, this probability will be, now favorable cases, it is 1 by 4 n into n minus 2 if n is even. So it will be this 1 by 4, n in this case is 2n into 2n minus 2 divided by any 3 from 2n. So it will be 2n C3. So we'll write this as 1 by 4 2n minus 2, and this is 2n minus 1 2n minus 2 into 6. Now I'll cancel. This value will be 3 upon 2 into 2n minus 1, which is our second result. So this is the answer to this question. Now the question is, a multiple choice examination has 5 questions. Each question has 3 alternatives, out of which exactly 1 is correct. So probability of success is 1 by 3. Probability of failure is 2 by 3. And altogether we have 5 such questions. So basically it's a question of binomial probability. Now we need to find the probability that student will get 4 or more correct answers. So we need to find probability of x greater than or equal to 4. Now it will be probability of x equal to 4 plus probability of x equals 5. Now this is 5c4 1 by 3 to the power 4 into 2 by 3 plus this is 5c5 1 by 3 to the power 5. Now 5c4 is 5 into 2, and this is 1 divided by 3 to the power 5, which is 11 upon 3 to the power 5. Option C. Now this again is a Poisson's distribution question. Now mean here is 2. We have to find the probability that x is greater than 1.5. Now x cannot take decimal values. So basically this is probability of x greater than or equal to 2. Now we can write this is 1 minus probability of x less than or equal to 1. So it is 1 minus p x equals 0 minus p x equals 1. Now we know that in Poisson's distribution, x equals x is e to the power minus lambda to the power x upon factorial x, where lambda is average. Now average in this case or mean is given as 2. So it will be 1 minus e to the power minus 2 to the power 0 upon factorial 0 minus e to the power minus 2 to the power 1 upon factorial 1. So it will be 1 minus 3 upon e square, and that's your option C. Now here the question is, Mr. A lives at origin. So Mr. A lives at 0, 0 and he has his office at 4, 5. So his office is at 4, 5. His friend lives at 2, 3. So we have this friend living at 2, 3. Now Mr. A can go to his office traveling from one block at a time, either in plus y or plus x direction. If all possible paths are equally likely, then probability that Mr. A passed his friend's house is shortest path for any event must be considered. Now first we need to find total number of ways in which this man A, he can reach his office. Now in order to reach his office, he must travel 4 blocks in x direction and 5 blocks in y direction. So total number of ways will be total arrangements of 4 horizontal and 5 vertical blocks, and it is given by, now total is factorial 9, 4 horizontal are same and 5 vertical are same. So it will be this factorial 9 divided by factorial 4 factorial 5. So this is your total number of ways of reaching office. Now we have to find the cases when he reaches his office visiting his friend. Now first he needs to visit his friend. So this farewell will be, now we have 5. So it will be this factorial 5 divided by factorial 2 factorial 3. And here we have 2 and 2. So it will be factorial 4 factorial 2 factorial 2. So this required probability will be this favorable case factorial 5 factorial 4. Now this is factorial 2 factorial 3 factorial 2 factorial 2 divided by this, which is factorial 9 factorial 4 factorial 5. Now this is factorial 4. This is 9, 8, 7, 6, and this is 4, 3, 2, 1. Now 2 will cancel. 2. This is 4. And factorial 5 is 5, 4, 3, 2, 1. Now this 4 will cancel. This is 3. So we'll get this as 10 by 21, and that's your option B. So basically it's a grid problem which we have already studied in permutations and combinations. Now here the question is, if f is a set of all onto functions from a to b. Now in this set A we have n elements, a1, a2, an, and in this B we have 3 elements which are x, y, and z. And f belongs to f is chosen randomly. What is the probability that f inverse x has 2 elements in it? And second part is f inverse x is a singleton. So basically here we are not talking about inverse function per se. Since it will be a many-one function, it cannot have inverse function defined for it. So basically what we are looking for is pre-images of x. So for the first part, it says this x has 2 pre-images, and for the second part it says it has only 1 pre-image. Now for this, first what we'll do is we'll find number of onto functions which can be defined from this set A to set B. So we have to find total number of functions that can be defined. So what we'll do is, from total, we'll subtract all those cases in which at least one of the element is missing. So for each element, we have three choices. So total number of functions that can be defined from A to B, it will be 3 to the power n. Now minus this first case when x is missing. So it will be this 2 to the power n. For y is missing, again 2 to the power n. For z is missing, 2 to the power n. So it will be this 3 into 2 to the power n minus this case when two of them they are missing. If xy is missing, all of them they go to z. So it will be this minus 3. So total number of onto functions from A to B will be given by 3 to the power n minus 3 into 2 to the power n plus 3. Now for this first one, now f inverse x has two elements in it. Now which two? So from these n, we can select any two in NC two ways. Now these two, they are mapped to x. Now remaining n minus 2 elements, they must be mapped to y and z, and it must be an onto function. So total number of functions is 2 to the power n minus 2 minus 2 cases when all of them they are either mapped to y or they are either mapped to z. So this required probability, it will be nc2 2 to the power of n minus 2 minus 2 divided by 3 to the power n minus 3 into 2 to the power n plus 3. And then the second case where this x has only one pre-image. So for the second part, we have to select one pre-image, it is nc1, and then for the remaining n minus 1 elements, we have to define an onto function from A to y and z. So it will be 2 to the power of n minus 1 minus 2. So this required probability will now be nc1 2 to the power of n minus 1 minus 2 upon 3 to the power n minus 3 into 2 to the power n plus 3. And that is the answer to this question. Now here the question is, if n integers are taken at random and they are multiplied together, show that the chances that last digit of the product is 1, 3, and it should be 7 also. 1, 3, 7 and 9 is 2 to the power n upon 5 to the power n. The chances of it being 2, 4, 6 and 8 is 4 to the power n minus 2 to the power n upon 5 to the power n. Its being 5 is 5 to the power n minus 4 to the power n upon 10 to the power n, and that of its being 0 is this value. Now we know that last digit on any number could be 1, 2, 3, 4, 5, 6, 7, 8, 9 or 0. Now we multiply any number with 2, 4, 6, 8 and 0. It will be an even number. We do not want that number to be even. And we multiply it with 5. Then it will either end with 0 or with 5. So that means we cannot choose 2, 4, 5, 6, 8 and 0. So the chances that last digit of the product is 1, 3, 7 and 9. If we choose the numbers whose last digits are 1, 3, 7 and 9. So that means this probability should be 4 by 10. Now it should be 4 by 10 for the second number, 4 by 10 for the third number, and it goes all the way up to 4 by 10 for all the n numbers. So this is nothing but this is 2 by 5 to the power n. So this first case when the last digit of the product is 1, 3, 7, 9 is 2 by 5 to the power n. Now the second one is chances of its being 2, 4, 6 or 8. Now if it is 2, 4, 6 or 8, then from these 10 numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, it should not have 0. It should also not have 5, and it should have at least one of 2, 4, 6 or 8. So from these 8 numbers we can form 8 to the power n numbers, and from this we'll subtract all those cases in which none of 2, 4, 6 or 8 is chosen. So there will be 8 to the power n minus 4 to the power n divided by 10 to the power n. So this required probability will be 4 to the power n minus 2 to the power n upon 5 to the power n, and that's your second part. Now in the third part it says the probability of its being 5. Now it will be 5 when out of these 10, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0. It should not have 0. It should not have any of these even numbers, and it must contain at least one 5. So total number that can be formed is 5 to the power n minus all those cases in which 5 is not included, 4 to the power n divided by 10 to the power n, and that's our third probability. And finally we have this where it says the probability of its being 0. Now basically all these 4 cases, they are mutually exclusive and exhaustive. So first we'll find sum of all these 3 probabilities. Now say it is P1. Now this is 2 by 5 to the power n, which is 4 to the power n. This one is 8 to the power n minus 4 to the power n, and this is 5 to the power n minus 4 to the power n upon 10 to the power n. Now here 4 to the power n will cancel. So the required probability is complement of this. So it will be 1 minus, and this is 8 to the power n plus 5 to the power n minus 4 to the power n upon 10 to the power n. So it will be this 10 to the power n minus 8 to the power n minus 5 to the power n plus 4 to the power n divided by 10 to the power n, and this is what we need to prove in this question. Now here the question is, X and Y are 2 weak students in mathematics and their chance of solving a problem correctly are 1 by 8 and 1 by 12. So probability that X solves the problem correctly is 1 by 8 and Y solves the problem correctly is 1 by 12. Now it says they are given a question and they obtain the same answer if the probability of common mistake is 1 upon 1, 0, 0, 1, then the probability that answer was correct is A upon B, where A and B are co-prime. Then find the value of mod A minus B. Now let us consider 2 events. Event E1, when both of them they solve correctly, and then this event E2, when both of them they solve incorrectly. Now this probability that both of them they will solve the question correctly, it is given by this probability of X into probability of Y, since they are solving the problem independently. So this probability will be 1 by 8 into 1 by 12. So it will be 1 by 96, and the probability that they will solve the problem incorrectly, it will be this Px naught into Py naught. Now Px naught is 7 by 8 and it is 11 by 12. So there will be 77 by 96. Now let A be the event that their answers match. Now if both of them they have solved the question correctly, then the probability of their answer matching will be 1. But if they have solved the problem incorrectly, then probability of their answer matching, it is given by 1 upon 1001. Now we need to find the probability that their answer was correct, given that they obtained the same answer. So basically it's a problem of Bayes theorem. So we have to find probability that their answer was correct, given that they have a common answer. So we'll take this case in the numerator. So it will be this 1 into 1 by 96 upon 1 into 1 by 96 plus 77 by 96 into 1 upon 1001. Now this 96 will cancel. Now 77 divided by 1001 is 13. So this probability will be 13 by 14. And that's your A upon B. Now modulus value of a minus b is simply 1, and that is the answer to this question. Now here the question is 7-digit numbers are formed using the digits 1, 2, 3, 4, 5, 6, 7, 8 and 9 without repetition. The probability of selecting a number such that product of any 5 consecutive digits is divisible by either 5 or 7 is p, then 12p is equal to. Now first we'll calculate total number of numbers that can be formed. Now total number of numbers that can be formed is simply 9c7, and then once we have these 7 digits, we can form these numbers in factorial 7 ways. So it will be this 36 into factorial 7, and that's our total number of ways. Now we'll calculate favorable number of cases, and for that what we'll do is we'll take 3 scenarios. Case 1, when we have not included 5 and we have not included 7 in the 7 numbers. So if we have not included 5 or 7, then we are left with 7 numbers. So in that case, total number of numbers that can be formed is factorial 7, and all these numbers, they won't be divisible by either 5 or 7. Now we'll consider the second case when exactly one of 5 or 7 is included. Now in this case, which one? So from these two, we'll select one. So it'll be 2c1, and then from the remaining 7, we have to select 6. So there'll be 7c6. Now it's a 7-digit number: 1, 2, 3, 4, 5, 6, and 7. Now it says any 5 consecutive digits is divisible by either 5 or 7. Now if we take 5 consecutive, it'll be this from this side, and it'll be this from the other side. Now if 5 or 7 they appear in the middle 3, then in that case those numbers will be either divisible by 5 or 7. Now we want the numbers which are not divisible by 5 or 7. So that means this 5 or 7, they must occupy a place from these 4 places. So for 5 we have to choose one place, and that can be done in 4c 1 ways. And then we can arrange these remaining 6 numbers in factorial 6 ways. So that's our second case when exactly one of 5 or 7 is included. So if there is no 5 and no 7, all the numbers are not divisible by 5 and 7. For second also, these are the cases where the number formed is not divisible by 5 or 7. We are solving this question using exclusion. And then this third case when both 5 or 7 are included. Now if both 5 and 7 are included, in that case, we already have 2 numbers. That means from the remaining 7, we have to select any 5. So there will be 7c5. Now the numbers formed by them must not be divisible by 5 or 7 for any 5 consecutive digits. So it can happen if number starts with 57, then we'll have 5 digits which are consecutive and not divisible by 5 or 7, or it can be 75, or it could be numbers ending with 57 or numbers ending with 75. Then there is this another possibility when number starts with 5 and ends with 7. So we have group of 5 which is not divisible, or it is 7 and 5. So we'll have 6 cases in which we can position 5 and 7. So it will be this into 6, and then we can arrange these remaining 5 numbers in factorial 5 ways. So these are the possible cases where number formed is such that any 5 consecutive digits are not divisible by either 5 or 7. Now we'll calculate this probability using exclusion. So this probability will be 1 minus, now this is factorial 7 plus 2c1, 7c6, 4c1, factorial 6 plus 7c5 into 6 into factorial 5 divided by 36 factorial 7. Now this is 1 minus, now this is factorial 7. Now 7c6 is 7 and into factorial 6 is factorial 7 and this is 8. So it will be this 8 into factorial 7 and plus, now 6 into factorial 5 is factorial 6 and 7c5 is 7c2 and 7c2 is 7 into 3. So it will be this 3 into factorial 7 divided by 36 factorial 7. Now this factorial 7 will cancel. So we can write this as 1 minus 12 by 36, which is 2 by 3. So value of this probability is 2 by 3. Now we need to find the value of 12p. So 12p will be 12 into 2 by 3, which is nothing but 8, and that is the answer to this question. Now here the question is, there are 5 students S1, S2, S3, S4 and S5 in a music class. For them there are 5 seats R1, R2, R3, R4 and R5 arranged in a row. When initially the seat Ri is allotted to the student Si, but on the examination day the 5 students are randomly allotted the 5 seats. Now find the probability that on the examination day student S1 gets the previously allotted seat R1 and none of the remaining student gets the seat previously allotted to him or her. Now if S1 goes to R1, there is only one way and none of the remaining 4 students must get their previously allotted seat. That means we have to dearrange these 4 students, which is done by D4 divided by now total number of ways of arranging these 5 students in 5 places. It is factorial 5 and this is the required probability. Now we need to calculate D4. Now D4 is factorial 4, 1 upon factorial 2 minus 1 upon factorial 3 plus 1 upon factorial 4. Now this is 12 minus 4 plus 1. So it will be 13 minus 4, 9. So this probability is 9 by 120, which is simply 3 by 40, and that's your option A. For I equals 1, 2, 3 and 4, let Ti denote the events that student Si and Si plus 1 do not sit adjacent to each other. Now T1 is S1 and S2, they are not adjacent. S2 and S3, they are not adjacent. S3 and S4, they are not adjacent, and S4 and S5, they are not adjacent to each other. So we need to find probability of S1 not sitting adjacent to S2 and S2 not sitting adjacent to S3, S3 not adjacent to S4 and S4 not adjacent to S5. Now here we have to consider certain cases. Now case 1 is when suppose S1 sits at R1. So S1 sits at R1. Now we have to choose possible combinations for remaining chairs R2, R3, R4 and R5. Now since S1, it cannot be adjacent to S2, so R2 can be filled by either S3, S4 or S5. Now S3, it cannot be adjacent to R2 and R4. So that means the only possible combination now here will be this S5. Now S5 cannot be next to S4. So this position, it has to be taken up by S2 and then finally it will be this S4. So we have this one combination which is S1, S3, S5, S2 and S4. Now if it is S4, it cannot have S3 and S5. So it will be this S2. Now then it will be this S5 and here we'll have S3. So we have this other case here. Now if it is S5, it cannot have S4. Now if it cannot have S4, then there are two possible options for R3 and they are either S2 or S3. Now if it is S2, it cannot have S3 as its partner. So then it will be this S4. Now the only option available is S3. Now in this case, it violates the condition. So it is not possible. Now if it is S3, it cannot have S2 and S4, and these are the ones which are remaining. So in this first case, we have only two choices. So for S1, we have only two choices. Now if we look at the second case when S2 takes R1. Now if S2 takes R1, then there are two possible options. Either it can be S4 or it can be S5. Now if it is S4 here, now 4 cannot have 3 or 5. So that means the next one has to be S1. And if it is S1, here it could be either S3 or S5. And if it is S3 here, we'll have S5, and here we'll have S3. So we have two cases here. And if it is S5, it cannot have S4. So we can have either S1 or we can have S3. Now if it is S1, then we are left with S3 and S4. So if they are placed, they will be placed together. So we have no possibility here. And if it is S3, then next one will be S1 and then it will be this S4. So we have three cases. So it will be these three cases now. Now if we look at S3, then the options here are either S1 or S5. Now if it is S1, then we can take S4, S5, and if it is S5, we can take S1, S2. Now if it is S4, then the next one, it has to be S2 followed by S5. So we have one case here. If it is S5, then it will be this S2 and S4. Again, this case is possible. Now if it is S1, then it will be S4, S2, and here it will be this S4 and S1. So for this third case, we have four possible arrangements. Now if we look at S1, S2, S3, S4 and S5. Now the condition for S1 is same as condition for S5, and condition for S2, it is same as condition for S4, and S3 has its condition of its own. So total number of favorable cases will be this 2 into 2 for S1 and S5 plus 2 into 3 for S2 and S4 plus 4, which is for S3, divided by total number of ways of arranging these 5 students in 5 places, which is simply factorial 5. Now this is 6 plus 4, 10, 10 plus 4, 14, 14 upon 120, which is 7 by 60. So this required probability is 7 by 60, and that's your option C.